Rang the bell gang. Indeed. Are the levels fine here? Let's see. Actually, let's briefly play some music. Copyright stricken immediately. Could you hear the music? Probably, right? Not that we need any desktop audio, to be clear, to be honest, because we're not going to be reacting to videos or anything like this. So as the title implies, we will not be doing any Odin in practice stuff necessarily today. Probably we'll just be doing HTTP client stuff, and really it's not going to necessarily be some hyper instructive stuff, but rather just sort of diving in a little bit and seeing what we can do for now and so on. I'll probably show some code that I already have from other stuff and so on. All right, this is not what we want to open right now. Actually, it sort of is, maybe. We could open this section here. Making the assumption that 32 kilobytes for headers is enough for everyone for now. Indeed. Many of these assumptions have been made over the years. They are rarely actually useful. No, they're very useful actually. One of the things that I think people miss when it comes to certain languages is that making assumptions like this generally will allow you to, for example, not allocate and so on in certain code paths, right? You can say that we have this amount. That's the amount we can use. If we assume that, then we can just say that's the amount we have. That's an array. It has that amount of space, right? Whereas in, let's say, a higher level language, you wouldn't be needing to make that assumption necessarily, because fundamentally you basically always allocate. So for you, it doesn't matter, right, in that language. So, but here there's a qualitative difference between making this assumption and not making that assumption, right? Of course, we can get around this by just saying, you provide the memory, I just use it. Or you provide the allocator, and it doesn't matter where the memory in that allocator comes from, and so on. Actually, it's interesting that you will say that. It's I will say one of the things that actually makes using languages like this really nice, if I'm being honest, is that you actually get to be the dictator and so on. One of the things that fills me with disdain for certain languages is they sort of decide what's going to happen, and I'm not about to let some fucking machine tell me what to do. So yeah, no, but I think a lot of, you know, if you want control and so on, right? these types of languages are for you. And but yeah, so by the way, this is I believe this is really mostly a joke based on a quote by Bill Gates. Let's see. Yeah, that 640K of memory, as a kilobyte of memory ought to be enough for anybody. Of course, he may not have said this, right? Let's see what the article says. We're going to skip to the end because we're lazy. He vehemently denied saying that, at the very least. This much we can say. But yeah. So that's where this sort of thing comes from. But ought to be enough for everyone, for anybody. Let's fix it. Let's fix the quote. But yeah, so here I actually have some code for parsing headers, which is, of course, a thing you have to do when you have an HTTP client. And this is kind of boring. What we're going to be doing, though, is just for the purposes of this kind of live stream and so on, just put together some basic, client, basically, that says, connect to this, maybe send these headers and expect some kind of response and see what happens, right? So that's what the live stream is going to be about. There's nothing serious. It's not part of any series for now, and so on. But it might be the thing that sort of ends up being effectively part of the HTTP client content and so on. I also uploaded an announcement of a new series that I'm calling What Happens When, and so on, that will be about just going through the code that executes when we do something in code, right? So, for example, we want to dial some other computer, right, via a host name and a port. What happens when we do this, right? The different steps that we go through. And we'll go through it with a debugger and so on, and show that process and so on. So it's sort of about kind of learning what the standard library does, maybe why it does what it does to some extent, and so on. And yeah, so this, I think it should be interesting. It will be a little bit shorter, the content in that series, right? We won't need 1 hour long videos necessarily for a lot of these things. Even if we did, they should be not the majority, right? So it should be more like we end up maybe doing an hour for something particularly complex or interesting, right? But since there's no debugging happening unless we find a bug or something interesting like this, there won't be necessarily a bunch of time being spent not doing the thing, right? So it should be a fairly easy series to execute. What are we doubting, Michel? Exactly. The chill stream, or not being part of a series. No. I'm explicitly basically saying that that's at least what the title is supposed to say, right? Let's just chill and do some stuff, right? Because the series of like going through something will be more like those are actually very specific videos. Maybe, you know, they laser focus on something, right? I was thinking about what someone said yesterday during the live stream, right? They said basically, you know, it's more like I have this on in the background or whatever, and so on. So I figured we will make this stream basically this, right? Will basically be, in some ways, you know, we're just sort of chilling together, looking at some code and whatever, right? We do some stuff here and there, you know, but it's a little bit more like a live stream is, right? It's not just a live episode of Odin in practice, but rather we're just sort of here doing some stuff, you know, talking some shit, right? So that's kind of what I want it to be. Be right back. I'm gonna get some coffee, by the way. Coffee is not done, it turns out. Our coffee machine is very slow. Coffee machine is a little bit of an overstatement. It's just a normal brewer. That is normal by Swedish standards. I don't know how it is in other countries really, but you know. We do have an AeroPress, by the way, Misho. Yeah, V6. I still don't know what V60 is or whatever. But yeah, we do have an AeroPress, so I could potentially make coffee a little bit faster. We also have fancy coffee. I still haven't used it. I am currently brewing some Chibo, whatever. It's just normal coffee basically. So yeah, I still haven't gotten into the fancy, quote unquote fancy coffee, right? But yeah, I don't know. I'm a little bit, I'm like, I don't want to disturb the status quo necessarily. What if I'm disappointed with the AeroPress, right? Or whatever. Then I'll just feel bad. It's very irrational, of course. It doesn't make any sense, but it is what it is. Eventually I will use it, and then I'll probably be like, wow, this was good, or whatever. Ah, you were disappointed with the AeroPress. Uh-huh. Yeah, this is kind of what I'm afraid of. Not afraid. I mean, I'm just kind of delaying that feeling. You know, I don't want to have to face the fact that, yeah, I bought this thing, it's useless to me. You know. I was thinking of it, actually, it's interesting. Yeah, I bought it already, but there's an interesting thing there, right? I was thinking about this today. I was reading this, you know, thread on Hacker News about keyboards, because Happy Hacking Keyboard, whatever company, announced a new keyboard of some sort. I don't know. I barely cared about the source or whatever, like the actual reason we were in this comment section, right? But there was someone who posted like, how did they get so popular, you know? And this is probably, I mean, it's probably an unpopular opinion, but from my perspective, most of these keyboards and so on really become popular because of fashion and so on. And it's usually not because they're any better than anything else, right? But I think one of the key factors in this whole thing is people buy them, they pay a lot of money, right? And then, of course, it would be awful to buy something for $300, right? $250, let's say. And then it's bad, or it's really not that great, right? So there's a certain kind of cognitive drive to say that it is good, right? Or that it's much better than it actually is, at the very least, right? I will say 100%. I bought a keyboard for when you account for import tax more than $300, right? I don't use it. I don't recommend it. I would not recommend anyone to do that. What I use now is this. This is a completely normal classic keyboard from, this isn't even Microsoft Classic. It's not Logitech Classic even, right? It's Hama. It is probably a grand total of 30 leva or something, 20 leva maybe, which is approximately what, $11, $12. I've used this for quite some time now. I bought several, but I haven't needed to use several because they never break. And they feel just fine. They feel better than my $300 keyboard. So it's like, I don't know. I just don't recommend spending the money. And people assign all kinds of stuff to keyboards. Like, well, I have this keyboard. That somehow means something. I mean, not really. Right? It means you spent a lot of money on it. Right? That's basically it. Yeah, I mean, A4 Tech Extreme, this sounds, 20 leva 15 years ago, right? 100% this stuff. And I'm not saying this is for everyone, but I am saying that I can 100% say I should not have bought this keyboard for, more than $300 with import tax, right? It was a mistake. It was pointless. There were fancy switches inside of it, right? I guess you could argue it kind of feels nice-ish, but it's not better than anything else. And I don't believe that I just somehow bought the one brand that's somehow not good in that, right? I'm more inclined to just believe that there's a lot of post facto kind of justification, right? I spent a lot of money on this, so it must be good. That is basically kind of what I'm thinking, more than anything else. And MX Master, this is the Logitech mouse, right? Oh, okay. So keyboard, MX Keys is the keyboard kind of in that brand. And then you can't use both at the same time. You would have to buy another keyboard. Because you like the mouse though, right? I've heard good things about MX Master, the mouse. Though I'll say I did the same thing with the mouse as I did with the keyboard. Though to some lesser extent, I bought this brand Aula. And this mouse is good. Aula Reaper. I've never heard of these people before this, but it just sort of works. It's good. I can't complain. I'm in the bargain bin basically, getting these things, and they just sort of work. They just work out for me. I don't know. So they make headphones as well. Yeah, like I said, I've never heard of Aula before I bought this mouse. But this mouse is good. It's definitely good. It has a good set of extra buttons that I use a lot and so on. And it feels good, kind of good shape, good weight, and so on. Oh, which one are you using with Bluetooth? I would imagine the keyboard would be better with Bluetooth. Probably, right? Not much sure. I don't particularly like Bluetooth, if I'm being completely honest. Usually it's very disappointing somehow. Especially, in certain computers it's definitely really disappointing, Bluetooth. Oh, okay, so the MX don't work with Wine, as in if you run something in Proton on Steam, you can't use your side buttons. Hang on, I will be right back. I think my coffee is done now. All right. Have you ever been under a water rationing in a city? Anyone? As in, you basically there's a time period in which the water is turned off. Ah, there are 4 concurrent viewers, but I suppose. Yeah, weird. But yeah, so basically, are you having this now? Because this is basically what we have right now in Pleven. So, but it's not. The schedule, I will say, seems somewhat random. Ah, it's turned off because they're fixing it. No, we are having a shortage. As in, we're having a water shortage, which means that between certain hours during the day, they just straight up turn off the water. Which is, oof. Life gets, there are, I would say, I did not foresee certain, like how life would become difficult when you just don't have water certain parts of the day and so on. Like, it's very hard to foresee, how that would turn out, right? In the provinces, yeah. I mean, I've never had this in Sofia, right? In Sofia, this was just not something that's happened. We did have portions of the year that could be where the water's turned off because they are fixing some pipes, or hot water is turned off for some other reason. And basically they do this district by district and so on in Sofia, which also is new to me. I'll say none of these things have ever happened to me in Sweden, in 2 different cities. But, yeah, life is interesting, right? Sometimes. The whole year, as in, hang on, what? They don't turn it off for a year, surely. I mean, that would be crazy, right? Uh-huh. Right, so it can happen, you know, every now and then, basically. Sure, maintenance. Yeah, I mean, this is kind of normal, right? And they can warn everyone. Uh-huh. Once a week. Okay. Once a week is a little bit much, but at least they actually now I'm pretty sure they don't warn you. You just sort of learn that this is the case, right? Until 17, okay. Yeah, this happened actually in Sofia at some point. We basically had this exact scenario where they say a certain time frame, they overshoot that time frame, they say a certain other time frame to kind of, you know, give themselves a little bit of room, but it turns out it wasn't enough at all, and so on. I don't remember exactly what the scenario was, but it was something very similar to what you said, where, you know, first it's a few extra hours, and then suddenly it's like, nah, it's the majority of tomorrow as well, or whatever, something like this. Very interesting stuff. That was hot water only, I think, something like this. Clearly, they need to learn from us in the software industry. You know, the quality, staying on schedule, and obviously all of those things, right? Because we're so good at those things. Yeah, absolutely. I feel like they really need a scrum master. Yeah, that's the key component to any team, of course, is the scrum master. Uh, if only someone could tell me what the fuck a scrum master is actually doing. That wasn't just a bunch of BS. So, let's connect to something. We're gonna make just a new binary, basically. I don't remember here, but it's something like CLI args like this or something. Let's just try this. We'll see. Doesn't matter so much. Dips. So this is basically the build code we need. let's make http underscore client dot Odin here. This is going to be our main file. And this is in no way, you know, going to be sort of, it's not going to be a binary that's interesting. It's going to be just us trying out some stuff. So let's say that we actually want some arguments here, right? We'll probably do this like this. We're not going to do anything super interesting right now. We're just going to do this. And here we could just say host is arguments 1, and actually going to say if len arguments is less than 2. Yeah, something like this. So now, host is basically, I think, let's just say address actually. This will be fine. This Copilot thinks a lot, you know, it thinks very highly of Odin, I would say. Microsoft do not know what the libraries are sort of like in Odin. Now, granted, there is actually an HTTP server actually written by a guy called Leighton, and so on. He may or may not have a HTTP client as well. A client is much more trivial than a server, just to be clear. So I kind of believe that there's probably one floating around out there. That's not really the point behind making it, to be honest. So there are a few things actually that are interesting about the net library in Odin. We have actually a lot that we can do. So if I just do net dot here, we can actually see a lot of these things, right? So for example, bind here, that's for setting up a server, receive, send, close, resolve, and so on. So you can do actually just resolution here. If you want to do, you want to take some name and resolve it to an endpoint and then do something with that endpoint, right? Because if we look at dial is a function, dial TCP here, right? So first of all, there's something I kind of haven't really gone over in Odin called procedure groups. And procedure groups are just basically a very, very limited form of overloading, function overloading in Odin. So if we look at this here, we can see that dial TCP is a procedure group with 4 different functions inside of it, right? One of them is called dial TCP from endpoint. Then you have, dial TCP from address and port, dial TCP from hostname and port string, dial TCP from hostname with port override, right? All of these they can have different arguments and so on. The thing they have in common is that when you run dial TCP, or when you type that, right, what's going to happen is Odin will figure out, based on these procedure arguments, which one to choose. So it's just very simple overloading. There's no implicit overloading going on here at all. It's all a specific procedure group, right? So it's very limited. So basically, if we provide an address and a port like this here, we will get dial TCP from address and port, right? If we provide an endpoint, we get this one. Dial TCP from hostname with port override. It's a hostname which is a string, and then a port which is an int. Then we have this hostname and port string. This is one string that holds both of these, right? So basically, procedure overloading is there to give you the sort of an interface that can say, yeah, we will choose a specific version based on types, but it's so limited that there's nothing to really be confused about necessarily, right? And I think that's fairly neat. It's a neat solution to the problem, right? And you can always use the originals. So if I say net dial TCP underscore, we can see here that I'm getting suggestions for the actual functions that are in this procedure group, right? So it's a very neat solution to this. It's very low on complexity, right? If I'm debugging something, there's nothing to be confused about, right? You know, we didn't just import some code and suddenly we're getting some completely different code path that we shouldn't be expecting, right? Which is what you can get with implicit overloading, right? Someone has made an overload for something you are using, and now you're suddenly using that version, and you're like, sorry, what? Right? So I think that's very interesting. I think this kind of overloading kind of makes more sense if you want to know what's going on. But yeah, so we have these functions here. We can see here hostname import this string version here, right? Basically, we can pass the address we have to this, and that's it, right? And what we get from this is a TCP socket or and a network error potentially, right? So we can say here socket dial error is equal to this. If dial error is not nil, do something, right? Like this. Error when dialing, like this. We are not doing anything with the socket. Here we can of course do net close socket, like this. If we compile this now, let's see here, mkdir bin, and let's just put some example address here. Port required, of course. Now we connected and then we just basically closed, right? Now we could try to send something when we connect. Sure, this would not be unreasonable. If you're wondering what it's ignoring in this particular case, we can actually see this. Hang on, net send, rather, send TCP on the socket, and then this. You can see here bytes written, right? You might be wondering, why do I care about this? Well, we might not be able to send the entire content, right? So what we generally want is some kind of function sometimes that sends all of the content, as, you know, it sends as much as it can and sees is there any more left to send and so on. In this particular case, we're going to go ahead and assume that this content over here fits. We can see here bytes sent, right? Log debugf. This. Here we can expect something. And yeah, we can also do if write error is also a network error. This should not be %s, I'm pretty sure. Let's do v here. Same here. And here we don't want to receive TCP, we actually want a receive, like this. And here we can actually supply a buffer that it should fill effectively as much as possible, right? So we can basically say receive buffer, and we can say, you know, let's say that we want, you know, I think we should be able to do this. So we have a bunch of bytes, right? And here we could just say receive buffer. We're gonna slice that like this. General use. Define then general use is kind of what I feel about this question. So just to clarify what the question is Odin ready for general use already? You know, define that, right? I don't know that there is for me personally, there's no meaningful definition of that, you know, basically. Every language is in development all the time, right? It's being used in production, I can tell you that, right? There is a product, one fairly big product called Embergen that uses Odin. We can take a brief look at this. Embergen. Actually, we can check this on YouTube. So here, for example, here we have 8 months ago this release trailer. So just to preface this, all of the Embergen is basically a fluid dynamics effect system that in real time generates things like fire and liquids and so on, right? Smoke. And so all of the fire effects you see in these trailers, this collection of trailer moments and so on, are generated by Embergen, which is written in Odin. So have that in mind. So the question here is maybe, what does it mean, right? Production ready, or, you know, programming is programming. I will say this: you will not find a lot of libraries in Odin, right? That's just a fact. There aren't enough users to have a lot of libraries, right? You will also find corners of the standard library that have bugs in them. Right? So if that's something that scares you, then absolutely Odin will provide some roadblocks, right? I have made so far 3 patches to Odin, 3 PRs for different things. One of them was a bug, basically, in, no, 4 maybe PRs. Anyway, so 2 of them were bugs. One of them was in how we resolved host names and so on. And that was a breaking bug, as in basically it didn't behave correctly on Linux for common setups, right? So I had to do that, right? In order to fix this and make it, you know, then you were able to use it, right? Right, if you're developing for Haiku though, C++ is the blessed language on Haiku, right? If I understand correctly. I mean, it was a long time ago that I looked at Haiku, but Haiku basically, as far as I understand, has a fairly good setup for C++, right? So I would be surprised if C++ was not the best choice for Haiku applications, to be honest. Because they also have good system integration, if I understand correctly. I might be mistaken, to be clear. But I would say this, right? If you're doing something where you can write the code yourself, right? Odin is going to be completely fine for you, I would say, for a lot of use cases. But when you stretch yourself to your limits and maybe there are things that you simply don't want to do, Odin will definitely present roadblocks for you. As in, the community is not large enough to have a lot of libraries, so you will not find libraries for things that you think are common, right? You will basically have to write things yourself, right? And this really only works if maybe you have a certain attitude and you have a certain, you know, you're prepared for this, maybe, Uh, so that's basically kind of where I feel like Odin sits right now, and probably for the foreseeable future as well, right? If you want to learn programming, and to me, learn the useful parts of programming and sort of how to relate to programming, Odin is a great choice, I would argue. Learning programming is not something you do with a bunch of libraries, not if you want to learn the useful parts, to me. I would say that there's a lot more you can learn from making things yourself, right? You just have to understand to pick basically things that are doable, right? Yes, you might not be able right now to write an entire GUI framework and so on, right? That might not be possible for you. I don't think that that's reason enough to say, you know, oh, I'm going to jump into just learning React immediately, right? Because the risk there, for example, if you were to, you know, you want to learn JavaScript, let's say, right? Let's say someone wants to do this. And they're like, but I really want to make things that are visual and so on. Well, the solution there is to make something that is visual but doesn't use a framework, for example, right? You can modify DOM components and so on yourself. It shouldn't be complex enough where you suddenly need to delve into this entire ecosystem, right? You're trying to learn, right? That is the actual purpose of what you're doing. And learning is best done when we actually do things ourselves, right? Of course, we can look at what other people are doing, but we have to do that with a certain eye, right? And that kind of thing is best developed from doing stuff yourself. So you have something to relate to, right? And all of this is just my opinion, to be clear, right? I'm not, you know, I'm not an authority on any of these things, but this is kind of how I view it, right? And certain languages, I think, have an easier time making things obvious for you, as in what's going to happen is what you wrote, and it's going to behave as you expected, or you described rather, right? Sometimes our expectations don't follow what we described, and that's where we find question marks, right? I had a lot of those question marks back when I was learning C++. You know, more than 20 years ago. Those question marks were often, I didn't know that was what I was saying, right? So I didn't understand what I was saying to the computer at certain points, right? Because C++ is incredibly complex. It's a very complex language. There are more holes that you can fall into where you think you're saying something to the computer, but you're actually saying something else, you know? The compiler basically takes what you say and just does it, right? It makes that code happen. And C++ is full of those things still today because of things like implicit overloading, RAII, and so on. A lot of code runs that you didn't know that you asked for, right? Odin is the opposite of that. Basically, I would say. There isn't a lot of code in Odin that runs without you saying that it should run, right? So you have a lot more control. And that control is not only useful for someone who, you know, needs that control for performance purposes and so on. It's also useful for people who want to understand what's going on and so on. So this is kind of what I would say Odin is good for when it comes to learning. The main difficulty, I would say, when it comes to learning with something like Odin is that it is not flashy, right? It can be very difficult to feel that joy of kind of creating some, you know, even just something like, hey, there's a stick figure running across the screen, right? That is not difficult to do in Odin necessarily, but it can take some time to get there if you're actually a beginner. And there are some things that you would have to understand. You would either have to kind of say, okay, I do understand some programming principles here at work and some programming basics and so on, maybe I can actually afford to use a library here to do something interesting and fun, right? And at that point, you could, for example, use SDL2 and so on, which is a rendering library that works for Linux, Windows, and so on. It's cross-platform and so on. So you could then use that and understand that you are not learning how to render things at that point, right? But you do want to make something happen, right? And SDL2 would be useful in order to kind of understand how does a game loop work, for example, if you want to make this kind of stuff, right? So you have to always keep in mind, yes, I can use libraries, but what am I learning, right? And so on. So you could take that leap at some point. But I would argue you need to spend some time just learning the stuff that sort of seems kind of boring, but is the magic that powers everything, right? What are the basic constructs for, like, I want to do this a bunch of times. I want to ask this question. If the answer is yes, I want to do this. If the answer is no, I want to do that. And things like this, right? Those things have to come first, right? And those things are very, happily, they are very, easy and kind of straightforward in Odin. Yeah, bugs in libraries are also, unfortunately, they are ever present, basically. And actually, it's interesting that you mentioned maturity of the project and so on. I worked on a project where we used actually the JavaScript AWS SDK and so on. And we found basically pathological cases in that interface where we had massive memory leaks and so on. And of course, as you know, JavaScript is used by a lot of people. And as you might guess, AWS, their SDK for JavaScript is one of the most well-used libraries, right? That didn't really matter, to be honest, right? There are just these cases in these libraries and so on. We probably could have actually implemented a lot of the subsets that we needed. Probably we would have for sure understood more of what we actually were using if we implemented them ourselves, right? And that's kind of the balancing act, right? This was, of course, like a commercial project and so on. So, it's not necessarily the case that we had time to sit down and re-implement a bunch of these things once the mistake was made and so on. I'm not convinced that C++ is in that much of a decline, if I'm completely honest. I don't like C++, just full disclosure. Not my favorite language. I don't hate it, but I certainly would avoid it for my personal, project and so on. I do think that there are interesting things in C++ and so on, but it's overshadowed by the fact that the language is so large that, it's very, difficult to get a handle on unless you have a very clear guideline and guidance in a company, for example, right? I think C++ is still not a waste of time. You can learn effectively how a computer does stuff if you use C++. Yeah, of course, like saying to the project, people, the stakeholders, we decided to rewrite the AWS SDK because it has memory leaks. They won't hear the part of the memory leaks, right? They will hear, we decided to not do work that has to do with the product because we're bored, right? Or something. It's just not super productive, right? But the truth is, all of these big libraries and so on, you're going to find these cases in big libraries. And the fact that they are so large and so on is the problem. They are very complex, right? Making things yourself, even in production, can often have the side effect that since we all understand much more what's going on and the surface area is much smaller, we actually get something better out of it, right? But again, everything has its limits. Like none of this is set in stone. It's not always a great idea to just sit there and re-implement everything, right? Because sometimes you just work in an environment where this is just not possible at all, right? If you're working for an American startup or whatever, odds are, you know, especially when they hire us, let's say, meaning people who are working from Bulgaria, then if some American company does that, they are basically expecting just a bunch of code to be pumped out, right? That's it. It should be done in the dumbest shit known to man, i.e. Node.js basically, and it should be done fast. It should be done now or yesterday, whatever, right? So that kind of situation, you're not going to be re-implementing shit basically. They don't want high quality work either, right? They don't expect it basically. So, you know. But yeah, so when it comes to C++, I'm not convinced that it's in decline to the degree that some people would believe. If you don't want to learn C++, I think that's also fine. Oh yeah, Bulgarian internet. It's very cheap, I would say. I have gigabit internet. I don't know exactly how much we pay. Let's see. Do I need to choose Plevin maybe? So 49 BGN per month, 4 gigabit, right? So if we 49 BGN to USD, it gives us $27-ish, right? So about $27 for gigabit internet a month is the level. I think that you're making a good point, Matthias, right? You need to understand the stuff that runs in the background pretty much always. You also need to understand kind of roughly how a computer works in order to understand what's going on. You need to understand that memory is really just a bunch of bytes inside of the computer, right? You need to, in some respects, understand how this memory is allocated as well and how that process happens and so on. There's just a lot of background stuff that you do need to understand. The only reason people don't think that is because they've sort of, I would argue, maybe convinced themselves that you don't need to understand any of those things. So yeah, I think you're making a good point, Matthias, that at some point you might need to understand the actual underlying code and so on. And this is actually kind of where I think Odin's side of this is coming in strong as well, right? If we do look into library code, and that's probably what you meant, right? The actual library code is going to be simple, straightforward. It doesn't do unexpected things and so on. Yeah, 50 euros for 10 megabits. That's a theft, is what that's called. Stealing from people, basically. I feel like that's a crazy price. But yeah, different countries, different infrastructures, different historical things, right? Some countries are maybe a little bit they were a little bit earlier to the internet with some of these things. Wow, I've been online for an hour. God damn. I haven't done anything. We've just been talking this whole time, which is honestly pretty nice. Yeah, these speeds are those are interesting speeds. I would say when we first got flat rate in Sweden, flat rate meaning a fixed price, right? And you were online all the time, right? So this was early 2000s. We were on a technology called ADSL. So ADSL is basically copper lines, basically. It is a broadband connection that works through the copper wires of existing phone lines, right? So effectively, it was just another phone line that you still did your, flat rate through, right? And you didn't pay a consistent or you didn't pay for your online time, right? So this was the first exposure I had to this. We got it around 2002 in Sweden. The speeds, I remember it was 0.5 megabit. I can't find this here now, of course, because this is probably lost. So maximum download speed was 1 megabit per second, maybe. I don't know. Actually, now I'm not sure what we had. But yeah, that was back in 2002, right? And eventually I got gigabit in Sweden as well through a company called Bredbandsbolaget, which is the broadband company. They were ridiculously cheap, in part because I was a student at the time as well. Oh yeah, actually, yeah. Yeah, simulating slow speeds, I think, does a lot to sort of inform people what it sort of means to have some of these things. Actually, a good illustration of this, I think a very powerful illustration of stuff like this, that people, don't think about stuff like this unless you show it to them. So this is a talk on
solving problems you probably...
it's basically a talk about architecting things in such a way where the machine can actually make sense of it. And also why that helps you also, right? And here's the animation that I'm looking for. Everyone should watch this talk, by the way. It is a good talk, very inspirational.
Our estimates, let's call it 200. So to give you some idea of what that means. So
this is now going to show loading from L1 cache, L2 cache, and L3 cache, or main memory, right? And the relative speed of those things, right? So first we're doing L1, obviously.
So an L1 axis is like this. All right, it's pretty fast. An L2 axis is like this. Right? And main RAM access. To scale. Right. All right.
Right. And if this doesn't make you cringe,
in reality,
who are you? Right? This is such an amazing illustration of the difference, right? And of course, you have to understand, how do I end up loading from RAM, right? Well, if something doesn't fit in L1 or L2, you will load it from RAM, right? If we had to, we will constantly be loading it from RAM in that situation, right? If we can fit one thing in the cache, right, you will very often load it from RAM to fill the cache. And this is the difference, right? You will be spending time effectively just waiting for memory to give you the actual contents, right? And this is happening obviously because of the bus in the computer, right? The design of a modern computer is such that we are basically just sending a bunch of content on one main bus, and then we're just sitting there. The CPU is waiting for this content, and so on, right? And yeah, illustrations like this are useful, right? Of course, it could be interesting to apply this, somewhere else. In browsers, we actually have some of these things, right? So we can always just go to the network tab and say, what would happen if I just said, I'm on regular 2G, right? Also very interesting. Right. Well, I mean, how much is this going to speed up stuff, to be clear? I'll be honest, I don't know enough about this particular thing to say, is this really going to be better, right? Because it is, of course, the relative speed that matters here, right? An L1 cache access is, a matter of effectively a few cycles, right? And so we get this kind of, that basically costs nothing, right? It's incredibly hard to beat. L2 is not much worse. I mean, it's worse, but it's not much worse, right? But once we go beyond that, we're paying incredible amounts of time, right? And so it's the relative factor here, right? We do want to stuff as much as we can in L1 and L2, right? Obviously, much rather would do it in L1, but yeah, I think the relative scale here is really what we care about, right? And this applies also to more things, right? So latency numbers every programmer should know, right? I don't think that we should read this as the Bible, right? But it's worth thinking about the scale of things, right? So you can see here, for example, reading 4 kilobytes from an SSD now is not relatively very fast, right? If we look at it from the perspective of, 0.5 nanoseconds for the L1 cache, right? Or even just the L2, or even just main memory, right? I suppose that would be nice, Greg. And I don't, like I said, I don't know enough about those developments to actually say anything of any interest in those regards. I would love for us to have massive scales of memory available at L1 cache speeds. That would be the dream, right? At that point, we don't really need to even care that much. The truth is, of course, I don't believe that any of those things will ever exist. But yeah, I don't know. We'll see. If it shows up, it shows up. I mean, it would revolutionize computers as we know them, right? Because a lot of problems are, they're basically caused by the fact that people would rather sort of, from laziness, they would rather end up somewhere down here, right? Just read some stuff from a disk, right? Instead of saying, hey, maybe I can actually be up here or whatever, right? So yeah, like I said, I would love for stuff to basically be at the level where, yeah, we have just tons of memory available at these speeds up here, right? Yeah, I'll save your message. How about that, right? I will save this message basically and look it up. I'm not going to react to it now, to be clear. That's not who I want to be, but I will save it. Let's see here. All right. But yeah, it would be interesting, back to what you said, Misho, your boys here, to have some kind of simulation of certain applications and essentially try to simulate that stuff, yeah. Basically run an application through, I guess in some sense, a networking emulator, the limited speeds, generally speaking. Because of course in a browser, again, we do have this throttling capability, right? We can actually say, you know, this needs to be at this speed and so on. But when it comes to applications otherwise, I'm assuming here that Mac OS has something like this, I would guess. They actually have reasonable tools for some of these things. Maybe Linux does to some extent. I haven't really checked it out. It would be interesting, yeah. Forcing a certain network speed and so on. And because you're doing emulation, what you would do is effectively kind of overwrite some of the syscalls probably, right? And so you could basically, for each platform, you basically have a set of system calls that you overwrite so that you can run your code, right? And at that point, you can actually kind of delay stuff and so on. So it would be an interesting project. I don't know that I would do it, you know, now, but it would certainly be interesting. But yeah, so effectively, I think this type of illustration, just to kind of give people a sense of scale, is very interesting. Because this is such a powerful message, right? Like I said, if you're seeing that, right? If you're seeing this part here in particular, right?
And L2 access is like this, right? And main RAM access to scale.
Already at this point, there should be some cringe, right? Effectively, we should be like wincing, right? At that point, because it's already too slow. And we're just waiting. We're waiting, right? And this is not like a critique of RAM, right? It is just allowing ourselves to end up in that position is why apps are much slower than they need to be in many cases, right? The fact that, you know, these massive amounts of memory might be passed around as if they're nothing, and so on. That's why we end up there. When arrays contain entire God objects, several of them, like thousands of them, even though we only need a very small part, right? And it would be trivial for us to just have an array with a small part, right? Trivial. But instead we say, nah, just massive array, God object inside of there. The object itself is, you know, just huge, right? That's kind of, in many cases, that's really the case, right? That's the reason we end up with just effectively doing everything from RAM, basically. And this is incredibly low-hanging fruit, right? It is so low hanging that it's basically it's on the ground, right? You just need to pick it up. Actually, no, it's at the height of your hand, because being on the ground implies that you have to bend down to get it, and that's not the case. You could literally just grab it. Very easy, right? So yeah. But yeah, I don't know how we ended up here. But yeah, Odin, it's a good language for learning. Perfectly positioned fruit, yeah. Incredibly conveniently positioned fruit. Perfectly hanging, indeed. That is what it is, basically. It is so perfectly positioned that you could just sort of, just thinking about it, you'll be like, oh yeah, hang on, let's do that. Right? But because we spend an inordinate amount of time kind of prematurely pessimizing our programs, right, for dubious reasons, right? We don't end up thinking about these things. The premature pessimizing that happens is usually of the nature of like, no, we need to architect our application this way, and so on. And even though that particular decision might not have anything to do with performance, it takes away time that could have been spent just sort of actually thinking about the behavior of the application and so on. Useless decrees given by, the seniors of the project who might sort of be obsessed or whatever it might be, and so on. Note that I'm not saying I haven't been this person or whatever. I perhaps have been. I will say I've mellowed out a lot over time. The truth is, most code in most PRs doesn't need that much. It doesn't need as much discussion as is being done. And the parts that are being discussed are not the parts that should be discussed, generally speaking, I would say. It's usually the wrong parts that are being discussed. I have found over time. The awkward part about this is that if you don't perform code reviews like this, if you stop, right? If you stop performing the code reviews that people expect, they will think that you're not kind of serious, right? Or you're not doing your job or whatever. Which is ironic, right? Because you are probably doing a better job than you were before. Oh yeah. Yeah, actually that's also a great part of our, premature pessimizing, that a lot of systems are just YAML files, right? A lot of systems are just a bunch of thinking about microservices, which is a great premature pessimization, by the way, because now everything is a network call, right? Everything is a network call to some other computer. Yeah, good luck with that. You're here. Round trip within the same data center. Look at this. And this is the stuff that people are doing. But you say, everything goes to a database. We're waiting for the database most of the time. Yeah, well, the stuff that you're doing in between could be faster, right? Sometimes it's a network call on the same computer. Not always, though. Especially if you're using Kubernetes, which might have pods on many different machines at many different times of the day, right? It depends, right? The pods could all be running on the same machine, right? They could. Maybe. Maybe not, right? We don't know because we've abstracted so much on top of all of this stuff that, we don't even know what computer we're running on anymore. Is it a completely virtualized computer on the same computer as all of our other services? Maybe. Well, I guess we'll see. And that's not a great position to be in, I think. Most things could just be literally the same program, actually. But yeah, people are not into that anymore. To be fair, though, I will say this: that not everyone is on the microservice train anymore, which is nice. But yeah, premature pessimization is interesting because it usually comes for no apparent reason, right? It's entirely made up. There are no reasons for it, really. The reasons might be just like we just like doing it that way. We always just work with this thing. And so on. It's never, premature pessimization does not necessarily come from an informed place of, reason. There's very little logic that goes into it. Which is interesting. Yeah, anyway. Back to Odin, I suppose. I do think Odin is a uniquely suited language for learning in that it can teach you a lot about the low-level stuff while also being very straightforward. And of course, there are languages kind of like Odin. If you want a bigger community and you want more libraries, you want a little bit of a higher level language, I would say Golang would be the most obvious candidate for learning. It's straightforward enough. It's in practice very fast. Certainly for the amount of time you have to put in. I said Golang specifically so we wouldn't be confused about this, Misho. It's Golang specifically. But yeah, I think Golang is a reasonable language to learn in order to learn programming and learn the basic kind of constructs that most programming languages will have to some degree, right? And again, it's high level enough where you can get stuff done reasonably fast without being super focused on the details and so on. I think Odin is the most straightforward alternative, or like most obvious alternative to Golang if you want to also learn more like this is how a computer kind of does stuff behind the scenes. It has a much clearer connection to actually what's going to execute, to me, right? But the obvious downside is, very small community, not a lot of libraries because of this, right? There are parts of the standard library that are less popular and so they will have bugs and so on. Those things I would say are distinctly different in Golang, right? And so in Golang you will find that the standard library is very well made, very well used, right? Pretty much all parts of it, right? Certainly if you're writing networked services and so on, it's probably the most well used part on any platform, right? You can also, it's interesting actually, I was thinking about this a little bit ago. There is this library Geo that actually is effectively IMGUI for Go, right? And I have no idea if we're going to be able to run this here, but this is a web version of this UI. So you can see here that we have a bunch of platforms we can run on, kind of like IMGUI in some sense, right? Probably a little bit more here, right? And we can actually write this stuff in Go, right? In Golang. And so you can see here that you can build, reasonably sophisticated UIs with this, right? Just as we would expect to be able to do with IMGUI. And it's, I think, straightforward stuff, as in the code that we have is probably going to resemble what we saw in the I Am GUI series, right? At least to some degree. I haven't looked into this, of course, but you can see here, for example, that we're effectively we're making an H1 here and so on, and we are, if I could see the output of this, maybe. Maybe I can't. Do I have to enable something? No. Okay, I'm confused about if we have examples here. Ah, here we have an example that works, and so on. Okay, this tutorial might not be the place to go, if I'm being completely honest. It's kind of confusing to some degree. Obviously, I'm skimming through it, but I would expect better stuff than this. Probably you can go to other tutorials here. Here you can see someone's making this egg timer here, right? And so on. And this is probably a better place to go and so on. We can kind of look at the code probably here to see what is the end result, right? What does it look like, right? Laying it all out. Okay, so it's a little bit different in that they have these flex layouts and stuff like this, probably a little bit of grid stuff. It's probably more inspired by HTML and CSS, right? Or CSS specifically, right? But fundamentally, it's the same principle. Geo is an immediate mode library, right? Basically. So for immediate mode GUIs in Go, right? And that could be an interesting thing to do as well. But yeah, Golang would be the alternative, I would say, to Odin in this. That kind of covers a few of the downsides of Odin, to me. I think that there are languages that are interesting to use for certain purposes, but for learning purposes, I wouldn't recommend those languages necessarily. Right? Obviously, you know, on this channel I have Haskell videos and so on. I don't know that Haskell is the best learning language necessarily. I don't think it's as bad as people believe, to be clear. But it's not what I would recommend, right? It has some unique difficulties associated with it. Not least the lore that surrounds Haskell that you have to constantly fight, right? People who don't use Haskell are often the most vocal about what Haskell is and so on, which I find very interesting. Yeah, it's a very strange relationship Haskell has with the rest of the world. I don't quite understand it. I have tried to understand it, but I stopped at some point. Equals is for setting things that already exist. So you can view it like this. If I have I is an int, right, like this, I is going to be 0, right? It's an int. The 0 value of int is 0. If I have I is equal to 2, I is now 2. If I would say, hey, there's a combination of these two, where I actually declare and set a value, I get j colon equals 3. But that also allows me to say, hey, j is an int. Like this. You can view effectively this as having an implicit auto type here. Right? So effectively that's what we're doing when we're setting no value. It will have whatever type this is on the right side. Right? We can also do this, which we sometimes do. Like I have a byte that is 255. And so, you know, in this case, if I left out byte, we would have an int, right? So that's not what we want in many cases. So we would need to do this, right? But yeah, so we can basically put a type here, which is exactly the same. So the syntax is malleable in that sense, where if we want to make a small change, we really only need to add one part or whatever. So colon equals represents essentially the absence of a type, an explicit type. We have the send buffer here. We're going to say here that copy to the send buffer the send string, and then we're going to say send buffer len of send string, like this. And here expected, what am I doing here? This undeclared name log. Yeah, so send string here is actually an untyped string. So if I want to send string C, I can actually say send string like this, which is a C string. Declare but not use is the error we get here, by the way. This is now a C string. If I want send string string, we can actually say this is a string and it's send string. And because this here is an untyped string value, it actually coerces to both of these if we wanted to. And so Odin has this concept of untyped constants that work in many different ways. They only work when they can work safely. So one of these would be every literal integer value is an untyped integer, right? And it will only work with certain cases, right? So for example, if I were to say an unsigned uint32 value, right? We could only really use values that make sense here, right? If I said this, for example, we shouldn't be able to do this. Oh no, in this case, we are not saying it's a U32, of course. Right, so you can see here, I cannot convert -1 to U32 from untyped integer, right? So any constant integer is an untyped integer. It can coerce to anything where it's safe and where it actually makes sense, right? Likewise with strings, right? We can make C strings out of them, and Odin will then basically make that happen, right? Because it can be done by the compiler, it's fine. And so when we use constants are always colon, right? That's why all function names and types are defined with colon, because they are constant, right? So if I have a type, right, like this, it's a struct, right? If I have a procedure, right, it's a prop, and so on. Colon is the thing we use for constants. We can actually define these wherever we want, wherever it's appropriate. When I'm working on something, I am actually defining something in line inside of a function, because that's where the rest of my code is, right? And so on. So both the types The procedures and so on can go there as well. And also these constant values, this send string here. I'm only really using this to have something to refer to, right? And so we can use that when we build up this slice here, because here I'm sending this send buffer here, which is just a slice into send buffer we've already copied some content into. So yeah, untyped values are basically at compile time values that can be coerced safely into other values, and so on. And so this is in reality a untyped string. It's not actually a string. Let's see here. Am I doing all I need to do? Let's see. I have not built this. Task HTTP client. Okay, we got a response. 404 not found. Though example.com is this not the what happens if I just say, hey, we're doing HTTP 1.1 400 bad request. We can't do 2. That is basically fundamentally different. Let's do this. Actually, what am I sending? Let's see what we're sending. Our send slice is going to be this. We don't need the new line here. Log never needs new lines, by the way. I'm not creating a logger, that's why we're not seeing any of these things, by the way. Context.logger equals log create new console logger, like this. Yeah, we are. Why would we get a 404 for this? What am I missing? I'm a little bit confused why we would 404 on get slash. Is it because we're on port 80? I can't do 443, right? We don't have any support for encryption and so on. Well, I mean, the scheme is really just a way to say, like, to the browser, hey, you should be on this port or whatever, right? And yeah, 443 would be the port for HTTPS, right? But port 80 is for HTTP, right? So if they're receiving connections on this, you would expect this to just sort of work. I'm a little bit confused why it's like this, to be honest. Let's just try something a little bit, just briefly here. Strings. No, that's not what we want. I mean, this copy that we had should do the right thing. It certainly should not be an issue of, because strings, by the way, are effectively U16, I think, in Odin. But when you copy here, it should basically just copy the ASCII into effectively byte by byte. So it shouldn't be an issue of essentially the copy here. But yeah, I'm a little bit curious why this is the way it is. Let's see if we can bytes here. What I'm looking for is basically here, you can see here we have buffer to string and so on. What I actually want is string to slice, right? That would basically remove, you know, any question I have about, is it just sort of the way I'm doing it now that's the issue? I don't think that's the way, or that's the issue, to be clear. But it's very useful to be able to rule this out. We also have a slice module that we can check. But yeah, I don't think that this is the issue at all. This copy here will just copy into the send buffer from the start. It will copy the send string content. We saw that that's in the send slice, we actually have this stuff, right? And so on. And that's what we're sending here. And what we're getting back is the 404. Let's try just something else. Just now we have this one. Let's say, well, google.com, they basically force HTTPS for sure. But let's say we do this, right? Yeah, from google.com we get 200 OK, right? So, I don't know. I think it's just example.com. It just returns a 404 in certain circumstances. I don't know why. It could be we don't have any headers or something, and that's just what it does. I don't know. If it would be understandable if it was a redirect we were receiving or something, right? But we're just not. So I don't know what to think, right? Anyway, doesn't matter. We're using google.com for this particular example now. So let's look a little bit at the parser we have. We have this parse headers function here. It takes data, which is a string. And that's not necessarily what we want, but at the same time, we can kind of work with this, right? I have a bunch of tests for this. You can see here that we're parsing a bunch of Cloudflare stuff, actually. I don't remember where I took these from. They're from something. But yeah, if we do run these tests, we can see task T here runs a bunch of these. This is actually based on a tokenizer pseudo library that I wrote. We can see here the functions that are involved in this actually. So the reason I'm calling it the pseudo library is because I have ended up copying this code into 4 different projects so far. And it's based on the idea that we have this tokenizer object, basically, which has source, we have an index, we have a current position, we have a line and column and so on. So it's inherently about basically parsing programming languages and so on. This is why I made it from the beginning. But it has this interface where we can expect certain things, right? So if we say tokenizer expect, for example, we can expect an exact token, for example, and a token here is one of these, right? So we have all of the symbol kind of stuff, left parentheses, space, tab, new line, etc. Then we can also have upper symbols and lower symbols, and these are symbols that start with lower or uppercase, right? We can also have single quoted strings, we can have strings, floats, integers, characters, and booleans, right? So it parses all of these things, and the main way we interact with it is basically we hold an instance of this tokenizer, and then we say things like tokenizer expect. And we can expect exact, which expects a certain exact token. Like if I expect a lowercase symbol that is called import, right? This will then give us that token, for example, or it will fail and we will get a token error, an expectation error. Right? Then we can have tokenizer expect here, which is more, we can expect a lowercase symbol, any lowercase symbol, right? It's in a project in Git, but I don't have a special repo for it, but I am going to put it in a repo very soon. Because I kind of want to put this in a repo so that I can use it as a dependency in my projects, basically, and so on. And probably I will end up making it as part of the HTTP stuff. We will probably end up using that library, right? So the tokenizer library will basically at that point be in a repo very soon, basically. And basically it's an imperative parser, just to be clear. It's very straightforward in that sense. It only tries to essentially say, you can say you expect this. If that is not, if we didn't find that, it will basically raise an error, you could say, right? But yeah, I think that this is fairly instructive, right? There are certain parts that are definitely about Odin more than they are about parsing, right? So here you can see, for example, we take out the type ID of your expectation and so on, and then we check, is it that type ID that we are holding on to when we get the next token and so on. But all of the logic that has to do with getting the next token, moving step by step and so on, is definitely reasonably instructive, I would say, right? And then I have more free-form functions like read string until. This is just sort of, yeah, honestly, I think you need this. Sometimes you just need this. And this doesn't work with symbols or anything interesting at all, right? It basically just says, hey, give me a list of end markers or whatever, right? And I'll parse a string. I'll give you a string that is as long as until we could find one of those. That's it, right? And this is obviously very, very useful for certain text-based protocols and so on, right? HTTP, for example, has new lines in certain patterns between headers and so on, right? So this tokenizer is basically based on a little bit of those things, right? You also have skip any of, like, hey, I want to skip any new lines and tabs in this particular case, right? Because certain languages will basically work like that, right? We can have, for example, any amount of white space here is going to be ignored, for example, right? And so on. So yeah, I think I will be putting this up online very soon because we'll probably be using it for a little bit of the HTTP stuff, because the parsing stuff is not necessarily the main point of those things. And so on. But we will want to kind of use it regardless. So yeah. This may or may not actually be the case anymore. Let's see. Yeah. Ooh, something failed because of that change. That's not what we want. Expected source token. What's the change then? I must have made some mistake here. Let's see. I mean, it seems unlikely that that would make anything different. Have I made some other change here? I mean, I changed this comment, and this will obviously not change anything. Let's see. This is a surprise now. This means effectively that code does not. Oh, no. Yeah, that makes sense. So just to clarify what I was doing here now. Yeah, so basically raw strings. This is a raw string, right? And everything in that string is going to be interpreted literally, which means these escape things don't even make sense anymore at all. So the situation I was causing here was this stuff was now behaving entirely irrationally. So that's why, actually. What we would want instead is basically this, right? Like this. I think that this was the version that was failing in terms of syntax highlighting before. Because this, the syntax highlighter was thinking, oh, hang on, that ends the string. But it doesn't, of course. And then it would think that this was starting a string, and all of this content would be assumed to be a string. And so that's this, the reason for this comment here is like, you know, the syntax highlighting just sort of breaks if you use a double quote in the string literal. So we're not doing that. Yeah. Now this should be fine though, because now we're obviously just escaping this, just as we're escaping these things over here, right? So the tests by any logic should pass now, which they do. This was just me kind of being confused, honestly, about raw strings or whatever for the moment, right? But of course, this stuff is going to be interpreted literally if we have these back quotes, right? Because raw strings are useful when you want, for example, a string like this, and then you want to say, hey, let's just put whatever content we want here, right? And this is now going to be just literally the actual content that's inside of the string, right? And so it's useful for like setting up examples of, for example, you have some raw HTML and you just want to put that in a string, for example, right? But it's not particularly useful the way I was trying to use it now when I was trying to fix this thing, right? At all. Now, however, we can remove this comment because it's not relevant anymore. But yeah. By the way, if you want some kind of example file and so on, you can also do this. So for example, we have some HTML content like this, right? Let's say we have this. And here we should be able to do this, basically. Let's see if we can find this on the Odin website. It's Odin overview. Let's see, raw file. This is, it's basically, I think it's a hash directive. It's load. Load is the one we want. Load string path or load strings path type, right? So here you can say, for example, HTML content should be load like this. Yeah, basically this. And now we would look for HTML content.html, right? So if you want to embed something in a variable like this, really this would be a preferable alternative if the thing is large. So this raw string thing doesn't necessarily, it's not necessarily the best choice regardless, right? So if you have, for example, shader files, right? We could have, for example, frag.glsl, for example, like this. Fragment shader, right? Or something like this, right? If we want to have that in a separate file, feel free, right? We can just use load, and here we can say that this is a string, for example. Be right back. I have to go to the bathroom. All right. Well, yeah, so if you want to load files and so on, a better way to do this, generally speaking, would be to use load like this. It depends on what you have, right? Sometimes you do want something to be in source, right? For example, I might want my fragment shader to essentially just be, this, right? In that case, we don't need to come up with any interesting, names for files and so on. And it might be that it's this basic, for example, right? In that case, we don't want a separate file for it at all. But this is useful mostly because we want something to be an actual variable in some program somewhere, right? It's not useful in the sense that, oh, this is a great way to write your fragment shader or whatever, right? But we do want it to have essentially, some type of binding in our program, right? So we can use it because this needs to be submitted for, creation of a program. And by program, I mean the actual terminology in graphics and so on, because a combination of shaders is a program together, right? Yeah, potentially it could be used for IntelliSense. That's exactly right as well, right? I don't know that is what's happening at all here, right? I don't think that we get that at all. No. It definitely does some level of, you know, this, right? So here, actually, let's try this. Tokenizer.odin. This is our own file. Aha, yeah, absolutely, yeah. If we do have a fragment shader, for example, we might have a plugin that makes, you know, writing fragment shaders easier, for example, right? We have shader language server, we might have all kinds of stuff, right? So it's good for us to have a separate shader file that makes all of that obvious, right? And so on. So yeah, that's true. Opa. Oh, hey Elsa. So my cat is here. She very badly wanted to be on stream. And now she's looking for an armpit to put her face in. And so on. Dale, Elsa. All right, let's see where we are at with this HTTP client stuff. We have this main file. Let's just parse the headers of this and see what happens. The read slice is actually where we have all of this stuff. And here we want to parse this. Where did I actually... We put this code somewhere. This takes a string, so it doesn't take a slice of bytes at all. Let's actually say strings here. And here we're going to try to strings clone from bytes. Right, this is now going to give us a string, right? So you can see here, it's either going to give us a, you know, some kind of, let's say S here, right? This is a string and a clone error, like this. If we had a clone error, sorry by the way for my typing right now, I have a cat on the keyboard, but we will get there. Now we can parse this, of course. So we can say parse headers, right, with S. This gives us a map of string to string, right? And we have potentially a header parsing error. Let's see what this gives us, right? So we can say headers and parse errors or error, right? If we have a parsing error, I want to see this. And here we don't want to say just parsing. I want to say parsing headers. And let's just sort of output this, right? Debug F headers like this. And here I'm going to actually just say hash v, right? And this will give us a certain type of output. We'll see if this even works now, right? We will see where it fails. And here we have unexpected character dash at 310. The snippet is -1 cache control and so on. Right, so it seems here expires. Ooh, in the parser, we're not parsing minuses here. Let's see. Dashes rather. Presumably, right? Let's see. We can easily add a test to see this, you know, in action, right? So, for example, here we could add to any one of these, effectively just right. So expires here we actually have a value for, so we can't actually use this test. That's fine. We can add one to potentially one of these. We could make a very, very small example here. So here we're going to say expires -1, and we should expect that to return us an expires header, right, like this, with simply -1 in here. I don't know why this would be a problem, but probably there's just, it doesn't factor in dashes at the start of a header value at all, right? So that's probably what's going on. So let's save that and see what happens. Now, to be clear, no, we should expect actually lowercase expires is what I would say. Let's see. Regardless, panic F. Right. Basically, we're just panicking because we have an unexpected character, which means the entire tokenizer at this point is basically not expecting this at all. So we're ending up in this code snippet here, right? Where basically we are not handling that character at all, which means basically we can just add this very simply. We'll add it under the underscore, case dash, right? Like this. And here is basically this. No, return integer is not what we want. That is definitely not what we want at all. Return just dash. This is not a token, by the way, presumably. If we go to token, we'll see, we can see the valid tokens here, and we can see that that's not one. So we can say dash is this, basically. Of course, we need to add this to our token value. We can add it here. But this is not necessarily going to solve our issue here, because in the parser, of course, when we say parse headers, right, we're obviously doing this a certain way. We expect a certain structure, and we expect one token presumably here, right? We create the tokenizer with the data we've been given, right? And then we peek into that tokenizer to see what's the current token. If we were to get a token right now, what would it be, right? If it's a new line, we just break. Otherwise, we get a header name, right? So we read a string until we find a colon, right? This is a very naive implementation, by the way. I'm assuming it's just, it should be more difficult than that. And then we basically set up a string builder, right? That is going to be the accumulation of whatever header values exist. And this is because headers in HTTP can actually have new lines in them and so on. And every new line is supposed to be handled a certain way. And so here we set up this while loop effectively. Whenever you find yourself doing this, by the way, there's a good chance you don't need this Boolean variable at all. You could just do this effectively, basically, because wherever you're setting this, you could just break, right? And there are very few situations where you can't actually do this. So probably here I would just say no, break here, right? Not that you have to do this, just to be clear. Like there's nothing that says you have to do that at all, right? In this particular case, we might leave this code because we know that it's ordinarily it works, and then we fix it later, right? So here you can actually see that we have this tokenizer read string until and so on. Okay. Misho, I will see you at some point. Have a nice evening too. Unexpected character A. AEC. Set cookie AEC equals. That's an interesting place to have an error though, right? That doesn't make a lot of sense. Let's see. A should not be particularly unexpected here, is what I would argue. The snippet we have starts with just AEC. This would mean that the tokenizer doesn't understand upper symbols at all, which I don't think is the case. We can see, of course. Ah, this could be a bug that I fixed elsewhere. That's the bug. So this is ridiculous, of course. This typo here basically has made it so that headers starting with A or B simply cannot be read. Which uppercase, to be clear. Lowercase work just fine, but yeah, that's ridiculous. Now we're parsing the headers just fine. Well, I say just fine. To be clear, I haven't looked deeply into the result here, right? Let's illustrate this result a little bit more clearly. Let's not do this headers like this. Let's instead do for VK in, actually it's a KV. I seem to remember it's the wrong order in Odin. We're just gonna do VK right now in headers. So, no, it's KV. I don't remember where I got this from, that it's the wrong order, KV. This is something that is the wrong order. I don't remember what it is. And here we can see the headers, right? So, actually I'm gonna make the output clearer. I just want my prefix to be there so I can see exactly what we're outputting. It's just confusing, otherwise we're just outputting too much text right now. So now we can see that, yeah, it is indeed parsing most of these headers as you would expect, right? I don't see one that is obviously broken, right? Here's the actual response, right? And I think we're catching everything. Maybe content security policy report only, that's a mouthful by the way, is actually cut off. No, it's not. No, it's fine. Now I was thinking this other HP value looked suspicious, right? It looks like something is being cut off, but no. So yeah, we're parsing the stuff just fine, right? This of course is the basis for what the HTTP client would actually do, right? We would just establish the connection, send whatever we need to. We're not sending anything particularly interesting right now, obviously, right? We're not taking any interesting arguments or anything like this. We don't even have like a get request, in fact, right? So probably what would go into this would be, you know, set up certain HTTP methods, right? Verbs in reality, you know, get, post, all of these things. And we would say, you know, give me a map of headers maybe that you want to use for this request. Inject those properly, use them when we make this request, and so on and so forth. Probably add, presumably we would add also compression support and so on. And in this case, we would probably just say, you know, gzip compression, right? We would probably just use the gzip stuff from the standard library in this case, very likely. I don't think it would benefit us too much to make that. We're already doing LC4 compression also as a series or whatever, so yeah, I don't know. Making gzip stuff would just be more of the same, except kind of worse, right? For most of the things that people want to do. So I don't think it would be super useful necessarily. By the way, I didn't respond to this when I saw it, Greger, but yeah, I do think, I don't know that Odin is really picking up pace necessarily, right? But I'm hoping that it can, right? But I don't think necessarily that my channel or whatever is going to be any driving force in that necessarily. I would love for it to be, right? Because I do enjoy Odin, and I enjoy doing videos on Odin, and so on. And I like Odin as a language for doing things in. And I would love for more people to know of it and so on. But yeah, I'm not sure that we are going to make a difference there necessarily, but it would be nice, yeah. And yeah, Sweden, I have no idea what people are doing, if I'm being completely honest. I'm so disconnected from, you know, what the Swedish market is doing and so on. I have very little contact with the development community in Sweden. Because I live in Bulgaria, I work in Bulgaria. And I guess you could say, you know, I'm more in tune with that. But even that's a stretch, right? I work in very small niches, right? So I've built pretty much the entire useful part of my career has been built on Erlang and Elixir, right? For backend services. So I don't know what's normal necessarily, right? In any country, to be honest. In some ways, I feel like I kind of live outside of a lot of that stuff. So it's not very in touch with anything, I guess, that much. I would love for, you know, I would love for Odin to be a thing, though. Yeah. I love using it for myself. So I'll be honest, like, this is kind of what I want out of it is just a language that remains simple enough where we can sort of just understand everything we're doing. We can do everything fairly precisely if we want to, and all of those things, right? Because I don't mind, like, my problem hasn't been, for a long time, my problem has not been writing code, right? Writing code is just something we do just to get to a result and so on. And so this idea that writing code is the problem and needs to be abstracted so much and so on has, to me, aged very badly. I think most languages are focusing on the wrong things in general. Elixir is actually a good example of this. People think writing the code is such a big issue when most of the problems in any system are just outside of that, really. And the solutions that they propose, like macros and all kinds of stuff like this, really only make the problems much worse. Even when the problem is to some degree, you know, understanding the actual code and so on, and having to traverse the code, the solutions are terrible as laid out by most languages, right? The real solution is actually embarrassingly simple. It's to have something that is so straightforward that it can't possibly be, it's just not interesting, right? So I would say I probably favor a language called, you know, like Golang, much more than something like Elixir now. You know, for that purpose. I do love Erlang services or Elixir services and so on. Like I said, this is what I've built my career on, and I understand it to a degree where it's, you know, part of me. But I really like the system of Erlang. Not the language is pointless. It doesn't make a difference to me. It's the actual live system that matters, and the scheduler and so on. Yeah, a library like Ziggler would be interesting to some degree. I think Ziggler is a bit, I don't know. Okay, so my problem there, right, is I'm not the guy to make that, right? Which is to say that I'm not sure that I need it, right? Because Ziegler, one of the big things, just to give some context to everyone so they know what we're talking about. So Ziegler is a library made by this guy, Isaac Yonemoto, and he has made this library for making NIFs, natively implemented functions, in the Erlang ecosystem, making them in Zig, right? I have no idea why this account is called eXisa, because Isaac is the guy that made it, right? So I'm not sure why this is the case, but it doesn't matter. The idea here is that you can then define an Elixir module. An Elixir module looks like this. You have def module, some kind of name for that module, and do, and then end here, and everything in between is the module, right? So the idea here is that you can actually define Zig modules, right, or Zig functions rather, in Zig code and have them automatically inserted as natively implemented functions, compiled correctly and so on, into this module, right? So this sigil here, which is an anti-feature that Zig has, is going to basically take this string and do magic with it, right? And basically expose this function to Elixir, right? And now you can call it from Elixir like this, example fun, with, you know, these things, right? You can pass F64s to it, right? And this is cool. It's definitely, is undeniably cool, right? But this stuff, right? I'm probably not the guy to make this, right? That's maybe my main issue with it, because, so I did a video on NIFs defined in Odin, right? And my view on NIFs is basically the bookkeeping that you have to do in order to add a NIF, like let's say we define it in C, right? Is not very, it's not that much, right? And yeah, this is a good point, Raphael, where one of the things that I do want from this, right, is I would like to expose the allocator, the beam allocator, right, as an allocator for Odin. That is something that I would like, right? That bit I will do for sure, right? That's maybe the core difference I have in this regard, where I don't want this. This doesn't make any difference to me, right? Having a sigil that says O and then being able to use Odin, that would do nothing for me, right? However, basically using the, you know, the beam allocator as an allocator in Odin, absolutely, right? This would be neat. This would be very good, in fact, right? This part, I'm probably willing to work on, you know, because I basically at the moment live my life in some ways, you know, between these two ecosystems, right? So I'm definitely interested in this, right? And so probably I will do some work in this regard, and we'll see what kind of shows up, right? But yeah, Ziegler is undeniably very, very cool though. And if I was doing Zig still, I would probably use it, right? But yeah, as it stands right now, this bit here doesn't necessarily interest me from a feature perspective, because like I said, the bookkeeping you have to do is not that much, right? This is interesting. There's an Erlang transform for this. This I find interesting, right? This you can see here parse transform. You can add basically a transformer for code and so on, and in Erlang. But again, it's just magic. It's interesting magic, yeah. Though I have no idea if it's better than Rustler. I will say Rustler is. I mean, I've used it. I've used it in a few toy projects, and then we had one real project where I used it. It's a good alternative, I would say. Rustler is fine. I just don't like Rust, though. So it's like, you know, I can use Rust, to be clear, but I just don't like it. It's not for me. It doesn't focus on the things that I would like to focus on. It's almost embarrassing how long it's been without proper support for like custom allocators and stuff. It's, I don't know, just, yeah, it's I don't get it, if I'm being honest. Like, I don't know how you can focus on the stuff that they do and then just sort of have code that just magically allocates everywhere. They just sort of, they have no order to anything. Yeah, let's just say I don't get it. It's because this is a difference in values, right? There's actually an interesting talk on this by Brian Cantrill. Reflection of values, right? So he did an interesting talk on this. He also has a podcast episode. Actually, I will probably, no, actually there's an image from this that I think is interesting. Let's see here if we can find this, right? Where have we ended up now? What is this? Vimeo probably has this. Hang on. Hang on. There's a cat here. She's just sitting here, being a cat. Node Summit 2017. Yeah, so this video here, I'm glad it showed this screenshot. Can we please just play this video? I would love for this video to just be played. Yeah, I don't think meta programming is focusing on the right stuff. I think it's pointless mostly, to be honest. I mean, I wouldn't sort of have massive arguments with people about this. I've done plenty of meta programming and it's not something that I would recommend, to be honest. I've used advanced meta programming features. I've used less advanced ones. It usually leads only to pain, to be honest. And yeah, the workarounds to do basic stuff, I guess that kind of falls into what I was talking about before, where I don't think writing code is the problem, really, generally speaking. Certainly that's not the problem we're trying to solve, right? But I don't think it's the problem with software development either, right? And it is fairly trivial in most cases to make, for example, code generation facilities. And so I guess one of the problems I have a little bit with this, a language needs to have metaprogramming is, well, it's so simple to do when you need it though. So it's like, I don't know. But yeah, I mean, it's mostly just a difference of opinion, right? That particular part. So I don't know that like I said, I wouldn't have any massive arguments about it because I think it's unlikely that either part would convince anyone here, right, about this. Code generation is not a hard problem, right? It's very simple, I would argue. If you can control the actual pipeline of it, right? If you control the input, it's not a particularly hard problem, right? And I say this, as someone who has implemented code generation facilities for several languages, right? So I have one project. Here, for example, which is a language for defining types, right? And it outputs, basically you can define unions, structures, and so on with arrays, slices, optional values, and so on, right? And we can use generics and so on. And we can output these to these languages, right? So I've made a layer for Kotlin, Haskell, F#, D, and Python. This by the way was painful as fuck, but yeah, I don't think it's fundamentally a very difficult problem, like relative to everything else. I mean, it depends on what everything else is, of course, right? But I certainly wouldn't put it up there as like, oh, this is a difficult thing, because I just don't think it is, right? When you control the input and you know what the output's supposed to be, it's also a very easily worked on problem, right? Code generation, right? But it kind of depends, of course, right? What are we expecting, right? But yeah, I don't think metaprogramming is a solution to many things, to be honest. And I don't think Odin should have it. It would make it a bad solution to many problems, to be honest. But yeah, again, like, part of that is obviously just a difference of opinion, pure and simple, right? It's not, I think it also kind of depends on where you are at the moment in your career, in your mindset, and so on. I don't think writing code is a problem, right? And so abstracting the writing of code, to me, is pointless, generally speaking, right? It's not very often the case that the writing of the code is the actual issue. It's the debugging of the code, it's understanding the code, and when something kind of, for example, expands into too much, that's going to be an issue, right? Debugging it is going to be a problem, and so on. So, for example, if we take an example, like a concrete actual example of a language that has these facilities, right? Fairly advanced metaprogramming facilities, right? Let's see here. If we take a look at Elixir. Oh yeah. The sections here that we're gonna find on macros and so on. I'm hoping here that I can find a good example of. So for those who might not know, Elixir is basically at the level of a scheme in terms of metaprogramming, let's say, in terms of macros-ish. I want to find what I think is the most overused macro in all of Elixir. Here it is. The __ using macro, right? This makes it so that when you write an Elixir module, and here we can actually find this in, when you write a module, you can write this neat use directive here. Use Phoenix Live View. This can inject any code into your module, right? You would have to go to this use macro and see what it will inject. People use this everywhere. It's just everywhere. And there's very little, I would say, order to it, right? People overuse this all the time. This is a community that prides itself on saying, well, you shouldn't use a macro unless you need it. But yet, here we are. They overuse it all the time. Right? And this is what you get when you have macros. Right? And to be clear, these are not C macros or whatever. Right? C macros are not very powerful. They're not very disciplined. Right? They're fairly just sort of Rambo, whatever. Right? And they can only do a very simple substitution. Right? But the end results are not simple at all. Right? You can get stuff done with them. I'm not saying you can't. Right? But they're pretty crazy. Right? And so, yeah, and def is a macro, right? That one is a little bit more defensible because it effectively acts as a keyword, right? We need some way to define functions, and so that's how we do it, right? It's kind of, we can just sort of, fine. Use, however, is completely overused. It's just basically people put whatever the fuck they need in these modules, right? And they just sort of say, well, just use the use directive, and now you have a controller, a Phoenix controller. Now you have a view, etc. What the fuck is in this shit, right? Well, the truth is, whatever they decided that day to put in that directive, yeah, that's what's in there, right? It's just a bunch of overused garbage in the end, right? Elixir is a great example of what you get when people sort of they have this phrase, always prefer a function, right? They have this phrase to rely on, and then they can kind of convince themselves that that's what they're doing, but that's not what they're doing at all, right? They build entire libraries that have hundreds of uses of def macro for no reason. And there are very few libraries that have a good defensible reason for this, right? One of them is actually fairly interesting. It's a library that allows you to run code on your GPU, right? So they have certain macros that in certain environments are going to, basically generate code in certain ways. So the code they generate for certain environments are going to run on the graphics card, for example. The code they generate if you're going to run it on a normal CPU is different. A macro can be defensible here, right? There's a certain qualitative difference here, right? But in most of these cases, that's not the case at all. It's just an overuse of macros. And, this kind of undisciplined thinking, it is much, much harder to follow an Elixir application than it is an Erlang application of the same inherent complexity. And the reason is they make things that are harder to follow, period. And they do this under the guise of, well, no, it's simpler because we use these things. No, it's not. And again, I've built my career on Elixir and Erlang. If anyone should be like, no, this is great, it should be me. But it's not great. Not particularly. I mean, it comes with obvious downsides that people are willing to sort of just ignore, right? And I don't think it's not a win in my book. So I'm very happy Odin does not have any metaprogramming facilities. Is the short version of that, I guess. But yeah. Like I said, it's very unlikely that these types of discussions end up in something productive, to be clear. Because, again, it's at what point in your career are you, what mindset do you have, and so on. Sure, yeah, there are costs to things, and I believe the cost for metaprogramming is much, much larger than anyone is admitting. It's much larger than the win that you get, right? So, I was working on one project, one contract, and I was reading the source code for, let's see here if I can find this. Let's do... I want to find Yeah, nim_stu, this one. So I was reading some code. I think it's a beautiful example of why you just can't do random, like you can't just have features that are so powerful that, let's see here. Ugh, that's not the one. I'm trying to find, because I remember there was a part of this where they were inserting random code effectively into the callee's code, and you cannot see this at all. It is just completely essentially random. But now I don't know that this is nim_stu result, let's say. Because I got it from this status IAM style guide, right? And I believe it is this file. Results. What is that? Nim results. Let's try this one. It could be this one. Who knows, right? Let's see. Results.nim. So nim, by the way, is a language that compiles to native code. It actually compiles to C, which is then compiled to native code. For lack of a better word, it is incredibly crazy. Let's see here. All of these templates that you see here are going to insert the code that's below. Effectively just insert that code. It doesn't matter what's in scope. Nothing matters, just to be clear, right? It is complete Rambo stuff, right? So there's one operator that they've defined, the question mark operator. Eventually we'll find it. I thought there was a question mark in here. Yeah, there is. We will find it. Yeah, here's the question mark operator, right? This code here is basically going to be inserted no matter what's in scope. It has no sense of any hygiene or anything, right? You can refer to things in these templates that don't exist at all. And at the call site, it's not going to tell you, oh, this macro is using something that doesn't exist. It's going to basically just insert the code and hope for the best. And it doesn't do this in a way where it's kind of honest, I feel like, in some ways, right? Because D kind of also does this with mixins and so on. But I kind of feel like D is a lot more, there's a lot more built around it, right? It just makes a little bit more sense, at least. And D is one of those languages that sort of is like, no, we will always have the most powerful thing because we want the most powerful thing, right? So the trade-off in D is always, no, power is what we want, right? We don't want something that makes sense, right? And then they focus on the wrong things. Like they have bad support for custom allocators. You probably would have to build your own and so on, and all of these things, right? But the language itself is just like, no, more power, right? Basically C++ style in some sense, right? And nim, I found out kind of while trying to learn some of this, that it's basically thinking the same thing. More power, don't focus on the right things, right? They, for example, have no concept of passing an allocator to anything, right? You set basically the allocation model you want when you compile. That's all the control you have, which is ridiculous, to be honest, to me, right, at least. It makes no sense to me. You focused on making all of these fancy template systems, all kinds of stuff, right? Metaprogramming, up the wazoo, but you can't give me custom allocators. Instead, I have to basically say, no, I want GC. I have to say that on the command line. That's it. Or I want reference counting, please. That's all I can say. And this makes no sense. Like, you've given me the things that I didn't need, and you can't give me even the most basic other stuff. I don't know. This is, to me, just a massive misunderstanding of what the problem actually is. So I guess that is how I feel about all of this stuff, right? Metaprogramming tends to be for people who focus on the wrong things more than anything else, right? And these are the wrong things. Inserting random code into the call site and just saying, if they're referring to stuff that doesn't exist, we don't care, right? Stuff like this. Yeah, NIM to me is the epitome of NIM, right? The impression I'm getting from everywhere is basically NIM is essentially a research vehicle for the guy who created it. He's inserted essentially just stuff that he thinks is cool, but basically none of the things that you need in order to have something that makes sense, right? At least to me, right? I don't think NIM is useful to most people who like Odin, for example, or C. If you're writing C code today, there's absolutely no way you should like NIM, because it's so devoid of all of the things that you like, probably. Sure. I mean, I've spoken generally about metaprogramming as well, right? Because we don't have a concrete example necessarily, right? Yeah. I mean, again, you have your opinion. I obviously have mine. I think metaprogramming it tends to focus on the wrong thing. That's basically it. And again, I've used Racket, and I've used Elixir. I've used other Lisps, right? I like them, but really not in the sense that I would say, oh, this is the right thing, right? That's basically it. Racket code especially, I mean, of course, these are untyped languages, or dynamically typed rather, right? So you could argue that something like, for example, Shen, if anyone knows this language, Shen could be an interesting language because it is strongly statically typed, and it also has macros, right? This could be an interesting alternative, right? There's also other Lisps that are strongly statically typed and so on. These could basically make sense. I think it's difficult, to be clear, to do all of this stuff, because type checking fundamentally is difficult to do with metaprogramming as well. Yeah, I don't know, too simple for some things. That's kind of it's hard to kind of argue for or against this, right? Because yeah, okay, so I will say what I prefer from a principle point of view, right? I prefer a language that simply says, the complexity is simply in the solution here, right? It's not in the language. And what you tend to find with more advanced languages is that increasingly the complexity is in the language. And I have seen almost no evidence that the actual solving of the problem becomes any easier in these languages over time, unfortunately, right? So, and that's, using languages that have different types of complexity, right? So again, Elixir for, the complexity, and sort of we can make constructs on our own that match the domain and all of these things, right? That is a I found that that doesn't actually work that way, generally speaking. And certainly the ecosystem is much worse for it. And then another version of this where Haskell, for example, right? I've worked with Haskell, and in Haskell, the complexity is in the language, right? And the idea here is that a complex language will then allow you to solve problems simply. And I'll be honest, no, I have not found that to be the case, right? This is obviously the argument for example, Rust, right? Well, the complexity is all in the language and the compiler so that you can then solve your problem in a simpler way, right? And I haven't found that to be the case either. So it's a difficult thing, this, right? With something is too simple, right? Because the simple thing, at least the thing I do know, is that you can debug, right? Whereas, for example, there was this comparison, Golang, Rust, web server. Let's see if it's this one. I don't really remember. It could be this one. No, it's not this one. It's not this one either. Let's see. Golang, Rust, web server, Gin. I remember Gin was being used in the Go example. There are so many results that you can potentially get for this stuff. I don't know which one I should use here. We already opened one of those. So basically, I don't know if anyone has seen this, but there was effectively a video by, actually this could be the one. Maybe it is. There was a video by the Primogen where he reacts to effectively someone is making a comparison between a Golang web server and a Rust web server, right? Web service, right? Rather, right? And one of the key things here was basically the end result, right? Was basically the author of the article preferred the Rust solution, right? And it was an interesting thing, right? Because the key to making the Rust web service work was effectively add an import of a thing and then use a macro or a decorator for a function, right? And that is almost impossible to debug, right? And so this was kind of ignored, right? Because this article was not about, hey, is this going to be nice in 6 months? The article was, does the code look nice in some fashion, right? Does it look nice right now, right? Meanwhile, the Go version used Gin, which it didn't need to, by the way, at all, because everything they were doing exists in the Golang standard library. So we're talking a zero dependency web service, potentially, versus what the Rust version was, which was hundreds of transitive dependencies, right? This is almost impossible to debug, right? Because you have so many crates involved that how are you supposed to keep track of all of this, right? And of course, the end result looks kind of nice because you can do like, oh, hash get for this route on a function. And now suddenly there's a route set up for you, right? And stuff like this. But the combination, the actual, amalgamation that you get out of all of this, is it actually easy to debug when something goes wrong and so on? That is the actual thing that actually makes a difference at the end of the day, to me, right? And I think, how many dependencies do we have to worry about? It's also a question that I ask myself, when I'm working on a project. Do I really want, because I'm installing one dependency, do I really want 50 dependencies installed, right? And so I think that there are considerations here that are a little bit, it's not immediately obvious, right? But it's obvious once you put it into an actual kind of production / I'm trying to actually live my life and not kill myself kind of scenario, right? Where we actually need to understand how something works and so on. And I'm not on necessarily the Golang PR team or whatever, right? But that video was a great illustration of mindset, right? There are some people who would prefer to just sort of sweep stuff away and just say, nope, I'm gonna just add stuff, right? And then there are some people who just sort of fundamentally think differently. And the Golang version, you could read all of the code consistently throughout. The Rust version was very much, oh, there's a new section of code. Who knows how it behaves, and stuff. So I think that there are factors here that sort of, I don't know. It's a little bit difficult to say this kind of, oh, the language is too simple. Well, yeah, I don't know. I'll notify you when I find that complex languages actually help. I'll remember to find you and send you a message somehow, because so far it hasn't really paid off that much. Is it more complex than Go? I don't know that I have that much of an opinion necessarily, except I guess it depends on what you define as complex, right? So it kind of depends. But why? Why is it more complex, in your opinion? Because, yeah. To me, it would depend on how do we define complexity, right? Because, yeah, complexity can be, for example, do I need to understand how, how allocation works? For example, right? But, for example, if you look at it a different way, let's say you have a language that doesn't surface allocators, right, for you. They have now complected allocation with code. As in, they are now together, right? So in those languages, allocation and doing things are the same thing. That is complected. Whereas in Odin, allocation and doing things are not the same thing. They are separate. They are not twisted together. They're simple, right? So in Go, doing things implies allocation, right? So complexity is, we have to kind of define what the actual thing is. I define it as things being tied together in some sense, right? But it depends. I would love to hear this argument, though, because again, I don't have a strong opinion on this. But this is kind of how I view this, the calculus of complexity or whatever, right? That how many things are we kind of baking into to one, sort of. And there are high-level features that I think make things simpler, and there are high-level features that I think actually make things more complicated, right? And so on. But yeah, maybe this is a terrible medium for this discussion. I don't know, because I'm talking to a screen and then I'm kind of just waiting for the message. So yeah, I think macros increase complexity. Yes, definitely. But I don't know. I want to say, oh, that's obvious, but whatever. Again, this discussion is it's difficult to have that discussion, to be honest, right? It's a little bit kind of the thing is, I don't need to or want to offend anyone either, right? You know. Yeah, well, like I said, I view it as when things are connected when they don't need to be, they are complected. Right? So allocation is connected to, for example, just creating an array or whatever in Go. Whereas these would be separate in Odin. So that part is simpler. Right? You could also argue that many high-level languages that sort of have that view on things, you know, like high level is everything, for example. There's a complected layer under them that does everything, right? And it doesn't do it the way, you know, because the code you write has nothing, it has no connection to reality, what's actually going to happen, right? And of course, this is the case for all high-level languages, including, for example, C, right? But it's an issue of degrees, right? To what degree are we writing code that does not represent what's going to happen? Well, in Haskell, we do it all the time. The actual code that runs has no relation to the code we wrote, right? And you could argue that is complex, right? Very complex. That also creates situations where, for example, if we have a language that runs bytecode, for example, we often have a JIT, right? A just-in-time compiler, right? That is a complication, right? A massive complication, because the code that we actually run, there's an entire system dedicated to possibly making that fast, but we will never know. But we don't know before we run it. Will this potentially be fast? And so on. And that's a very complicated system, right? But I think the things that you're referring to in some ways, I would argue to be simple, but maybe you're instead saying they are something you're forced to learn, right? Sure. Yeah, a language can be complicated and a runtime can be simple. Sure, yeah. Absolutely. But, I mean, hang on, by the way, Golang has defer as well, no? But yeah, I don't know. Again, complex things, right? I almost feel, you know, like dweeb for recommending this, but it is a good talk. I'm gonna recommend it. Why not? There's a reasonably good talk by Rich Hickey on this. It will directly contradict some of my opinions, for sure. But it is a good talk only for, you know, it does inspire thinking, I would argue, right? So Simple Made Easy by Rich Hickey. This was back in 2011. Is a very good talk on simple versus easy and complex versus simple, complex versus hard, and so on. So one key to all of this whole discussion would be, for example, it's very easy to install a dependency. It's very easy to have memory allocated for you and so on. That's easy, but is it simple? It's not particularly simple, right? Simplicity is the non-interconnectedness of things, right? We don't need to know this because of this and so on. Things can remain separate and so on. And to some degree, some of those factors actually point to functional programming as being maybe more simple. In practice, I don't think that that's necessarily the case, though, right? I don't think that, Clojure is a massive mistake. It's a nice language, to be clear. But, it is, I think it is kind of difficult to define all of this, right? I do think that the closest thing we have is in some ways Simple Made Easy by Rich Hickey for talking about these things, because some people, when they say simple, they essentially are saying Chinese is simpler because I know it, right? But to someone else, Chinese is it's not, easy for them, right? What they actually meant is Chinese is easy for me because I know it, right? Whereas simplicity is an intrinsic thing. Something is simple because it's simple, not because you know it, right? Not because it's easy, right? Writing something into a terminal and pressing enter is easy. But that thing might be going to the internet, fetching hundreds of things, connecting them together. That's not simple, right? And so on. And there are many language facilities that are like this. It's incredibly simple to write a keyword, or easy to write a keyword, but it's not a simple facility, no matter what, right? And some things are not easy and they're not simple, which is the absolute worst, right? A lot of people would probably say Rust's async falls into this category, right? It's not easy to use and it's not simple. Oh, I don't know if it has less language features. I wouldn't honestly know, because I haven't used Go to that degree where I can say that that's the case. I mean, it's undeniably simpler than C++, yes. But that's also because C++, again, it actually complects things. One example of that is, for example, a variable falls out of scope. Suddenly a destructor is run that no one asked for, right? That's a complication. That's complected language facilities, right? Everything has effectively the drop trait from Rust defined on it, right? Destructors just run when something falls out of scope. That's complicated, right? Defer is simple. I asked to run this thing at the end of the function. That's simple. We have uncomplicated this, right? We have said, I want to not do things magically with values when they fall out of scope. So I take that behavior out, I give it a name, and I run it, right? That's simple. We have taken apart things that were together, right? So that's a great example of complexity versus simplicity. Defer is simple, right? Yeah, deferred out I really hate. I said this on the Discord. I would prefer it if deferred out did not exist. But, that's a little bit of a hot take, whatever. Spicy take, or whatever you will call it. Basically, Ginger Bill responded at the time, and he said he understood why I didn't want it. But he said it was added basically for GUI libraries, right? And so on. I'll be honest, I would rather take the hit. I would rather have not this complicated thing, right? That basically is magic. You have to actually look at the function you're calling to see what's going to happen. That's bullshit, right? As in, I should actually only have to look at the body of the function to see what's going to happen, right? But this deferred out stuff, no, I don't like it at all. But again, I mean, every language will have stuff that I don't like. I don't think I've ever used a language that is just perfect. It doesn't exist at all, right? Because, yeah, Odin is the best I've found so far for making things that I actually want to use later, basically, and I want to work on later. It's the best bet I have for any of those things, sadly, right? I wish there was something that just sort of fit completely, but it's never gonna show up. I'm too pessimistic for that, I guess. Sure. Yeah. There are situations. It's made for profilers and GUIs, right? Those are the two cases that Gingerbell said it was made for. So I am aware, right? And basically, I just sort of, I accept that that's the case. And then it's just one of those things where once in, I guess, a year or whatever, I might be bitten by this because someone has used it when they shouldn't have. And there were people in the discussion back then that basically said they use it for a lot of stuff. They use it even to free stuff and so on. And or like, you do a thing and it automatically frees something or whatever it might be. And I think that's a bunch of bullshit, to be honest. But again, this is actually kind of the nature. When you provide things that are shit, but you say only use this shit thing for these cases, guys. Guess what? People are going to use it everywhere. And that's just the nature of stuff. I would have a linter for this, I can say. Let's say I will. Let's just manifest that into reality. When I hire Odin programmers in the future, in our project there will be a linter specifically for deferred out that says, go fuck yourself. No, it says very politely, please don't use deferred out. And then it sends a hitman to the person's house to take care of the problem, basically. But yeah, no, deferred out is one of those things where this has definitely, it's exactly this RAI problem. It's used actually for some of the methods or some of the functions, right? So if we go to sync, there are going to be some functions that are going to use it and some that don't. Let's see. Sure, we can just go to here. And so let's see here if we can find this, right? At least this is how I remember it. To be clear, I'm not gonna be 100% certain of this. We're gonna have to look at some of the code. Yeah, guard uses this here, right? But then you can use the variants that simply don't do anything interesting as well. So yeah, some of them do, some of them don't. So the guard functions do. At least they're named very, like, consistently. You can basically see, okay, I'm using the guard one, right? So, But yeah, you can just use, try lock, unlock, etc. Yeah. No, everyone has a favorite case, actually, right? And that's kind of one of the issues. Everyone has their favorite kind of. Actually, this is just sort of how it is, right? It's like everyone has their own favorite C++ feature, right? And I have C++ features that I like. Like, these are my favorites, right? Some of them are well-informed. Some of them are less well-informed. But I have my favorites. Someone else has their favorites. And if we were to, try to make up a subset of C++, we would have to basically say, oh, everyone's favorite is in there, right? Which is, once you have a large enough group of people, this suddenly turns into all of C++, right? So one of the things that I like, for example, if we take a look at this PMR, let's see if I find this. Right, so PMR is basically the allocator subset of the standard library. I think it stands for polymorphic, what does it stand for? I can never remember this. Does anyone know? Polymorphic, monotonic something maybe? I'm not sure. Polymorphic memory resource maybe? Like if we had to go, based on this maybe. What a name, right? Basically it's custom allocators for stuff, right? I like this. This is just good. It focuses on the right stuff. It actually allows you to use the language in a way that fits in potentially everywhere, right? I don't know exactly how it works in C++. There, every time something is good in C++, there's always like, hang on, read page 5. Because page 5 details how wrong this goes when you do this and that and all of the other stuff, right? And so you have to read page 5 to actually understand that maybe this is not always the best thing, right? It's always like this, right? That's why there are C++ books, because the most of the book is just, oh, by the way, this doesn't work unless you define this particular method on this thing or whatever. And if you don't, it actually always copies 5 gigs of memory or something like this, right? So that's obviously like, I don't know the details of this, but I think this is focusing on the right stuff, right? Also, this maybe is more controversial. Lambda expressions in C++ are, this is a spicy take maybe, the best lambdas it's better than most languages. I mean, this was not such a spicy take. I had to, hold back a little bit, but most languages have worse lambdas, I think, than C++. In C++, you can control what's going to happen in a lambda. It's not just closures over everything, right? You don't automatically copy stuff. You don't automatically take references to stuff. You actually get to choose, right? So it's very sensible, right? I don't know that I like them, like I would use them absolutely everywhere, right? But as far as if someone were to tell me, oh, C++ has lambdas now, I would have thought that they were much worse than they actually are, right? Because they're not great at implementing features always, right? It's oftentimes a little bit suspect, right? Oh yeah, we have that feature, except page 5, So, and of course, again, I don't know the page 5 of lambda expressions, to be honest, except obviously like, hey, if you have a reference to something and that shit is wrong or whatever now, it's gonna go badly for you, right? Those obvious kind of things I know, but in terms of language features, I think lambda expressions are a massive success, right? And I think the design of them makes a lot of sense for C++. But yeah, the problem, I guess, is everyone has their favorite stuff, right? And in some ways, deferred in, deferred out, and all of those things are kind of like that, right? Everyone has their favorite use case for these things. And I guess I just would have preferred if we didn't have to have a favorite use case for this thing. Maybe is what I'm saying. mostly, right? But again, every language has a bunch of stuff that you maybe feel a little bit, iffy about, right? I don't think that deferred in is going to ruin a code base, or deferred out, whatever, right? Absolutely, it won't. And if someone is using it everywhere, you would just tell that person, please stop. Like, you don't need that everywhere. It's not C++, in fact, right? And maybe you could explain, personally, I would just try to explain to that person, I prefer if we instead, get what we asked for, not extra code, right? Sure, I can just not use it, but then again, the problem is other people. But this is always the problem. And again, I mean, this particular conversation has happened thousands and thousands of times, right? So yeah. But this is the actual problem, right? When there's always other people in the equation. Not always, to be clear. I would, I spent a long time writing C++ basically just alone, to be honest. If I went back to that, I don't think C++ wouldn't upset me at all, maybe. I don't know. Because I could just write my style of C++. I could use exactly those features that I like, right? And then I could reevaluate that based on, how is this going? Is it going well, And yeah, linters are a good way to actually get around this, right? I don't mind linters. Some people are like, no, if you have a linter, it means something is bad or whatever. But I think a company linter is a great way to just say, we prefer to do stuff this way, as long as it's friendly enough, right? It should basically be able to tell you, we prefer to not use deferred out here, right? Please look at the code base as it is right now and look at the use cases and see if it matches what you're doing. And if it does, add this line to ignore this warning. And that's very easy to pick up in a code review as well, right? Because you can just say, this is not one of those cases where you should be using deferred out, for example, right? You can tell that to your colleague, right? But yeah, the only complication there is, there are other people, they have opinions, right? Some are stronger than others and so on. And that's the only real problem with that situation. But yeah, having a linter for this is also not particularly difficult, right? And if you write it in Odin, it's probably going to be reasonably fast as well. It shouldn't really be a problem to run a linter on, a few 100,000 lines of code. We had one, I was working on a PureScript project. So PureScript is it's Haskell for JavaScript or Erlang or a bunch of other languages actually. So let's see here, purescript.org. So it looks vaguely like Haskell. It looks like Haskell. But it compiles to the original version or whatever, compiles to JavaScript. At that company, we used it for compiling to Erlang. And basically, first of all, compiling the code base, I think without caching and so on, I guess it took minutes. I'm not entirely sure how long it took, to be honest, because I don't think I ever did it necessarily. Except like the first time, like first compilation, walk away from the computer, whatever. I don't remember if I measured it or anything. It took forever. We also had a custom linter and so on, right? That gave warnings and blah, blah, blah. And that took forever, right? And I think those kinds of tools are really bad when they actually have those modes of operation or whatever, right? Because at that point, you're not exactly incentivized to run your linter. right? And that's a problem for sure, right? I don't think linters should be written in the languages that you use, actually. If the languages are not good enough in some respects, right? A good linter probably should be written in something a little bit more sensible performance-wise, like Go or something, at least, right? We've seen this a lot in the JavaScript ecosystem and so on, where as time moves forward, people realize, hang on, Zig is a better language for implementing this than TypeScript is, for example, right? Or the many tools that use Rust, or ESBuild that uses Golang, right? All of the highest quality tools that actually work fast and give good results are made in something else. And I think that's kind of obvious in some ways why it is like this, right? No one wants to run a tool that takes more than 10 seconds when it's doing a fairly simple thing on a few, honestly, just a few thousand even lines. Well, to be fair, okay, I don't think the JavaScript tools take that long on a few thousand, but you know, you get up to what, 50K, 100K or whatever it might be, and stuff just takes a long time suddenly, right? And it's just like, no, this should not be the case, right? We don't need that. At that point, you really need to consider, like, I don't think that this is very good, right? Well, some of them are for every, I mean, you're basically, it would be, for example, like a command that you run, but you want to run it locally. You definitely don't want it when on a remote commit, right? It might be local, a Git hook, for example. That kind of action is kind of what I'm talking about. But yeah, some of them are on save, to be honest, and you have to disable it because it's so slow. I've had this experience with Haskell tools on large enough code bases where you're waiting 6 seconds every save, right? And that's depressing. Hang on, be right back. So one of the situations that I remember was basically trying to work on the PureScript compiler, which is written in Haskell, right? And first roadblock was the tools that I use don't work, right? So for example, using the Haskell language server did not work on that repo, right? That's roadblock number one, right? Now you're not incentivized to, first of all, just work on it, period, right? And you don't have the tools that you usually use. So you're already kind of fucked up in some way, right? And then the actual compilation of everything in that repo, even with cached versions and so on. And it could be also because of the structure of the project, or particularly the modules that I was working on or something, that they have lots and lots of dependents, right? Which will need to be recompiled as long as, you know, you change that module. This took forever, right? We're talking like 5 seconds per save. But even when we're up at like 3, this is too long. Like, it's just bad. And we're talking basic compilation here, right? It wasn't even like, oh, custom linters doing interesting things, you know. It's just bad, right? And that's one of those situations where, I'll be honest, like, Haskell is very difficult to compile fast, I guess, right? Because it has lots of kind of global constructs. It's in some ways, Rust also kind of suffers from this, right? Where I don't know how much of, you know, the people who watch the videos now or whatever, people who are here right now and so on, that might be just one, I don't know. But Haskell has type classes. Type classes are basically just a way to define an interface and then implement that interface for a certain type. Those have to be unique and global. So what that means is, effectively, when I define an instance of a type class, I basically say, for strings, this is how we, for example, print them. Print would be a type class, right? And so in our code, we would say, this function is defined for any type that has a print instance, right? So they're kind of like interfaces in this regard, right? But they have this global restriction, right? This also means that you need a global repository in your compilation for these, right? And whenever there is an instance, basically, you know, that's needed or whatever, you need to effectively kind of remember that, yes, there is a global print instance table that I have to refer to. But the fact that it's global means effectively that we have to, in some ways, kind of compile more code in order to find this instance, right? It could be defined, you know, in multiple places by convention or by some restriction. In some respects, it's defined in the same module that has the type, right? Or it's defined in the module that has the class, and so on, right? But regardless, in some ways, you have to actually keep this massive table around, right? With these instances and so on. So the fact that something is global and so on can affect basically what we have to keep around and so on, right? But fundamentally, the problem with some of these things is the fact that Haskell is written in Haskell quite possibly could be the reason a lot of stuff is just slow, right? Because it's not as fast as something written in, typically it's not as fast as something written in C++, for example, right? And, you know, when language communities write tools in their own language, right, which they want to, yeah, Haskell is written in Haskell, yeah. Yeah, I mean, Haskell is certainly a lot faster than most high-level languages, to be clear, right? I don't want to give the impression that Haskell is somehow, you know, some kind of Ruby or something, right? Because it is hundreds and hundreds of times faster, right? OCaml tends to produce faster code, but not by much, yeah. OCaml is definitely, you would characterize it as being slightly faster than Haskell, yes. It also tends to maybe produce, because one of the problems with Haskell, right, is, this is a problem with all higher level languages, right, but maybe a little bit more is that it tends to box values more, right? So basically put them behind pointers, right? Which means you tend to chase pointers more in Haskell, slightly more than OCaml. But OCaml also has to as well, right? Because you can't have a list without boxing, essentially, right? For example. And OCaml tends to favor lists and so on. But it doesn't do this intelligently. Certainly not like some people think that, oh, no, but my GC is so smart that it allocates everything next to each other. We don't chase pointers, it turns it into an array. No, none of that is done in most cases. But yeah, OCaml is slightly faster than Haskell. Unfortunately, it has a runtime that's basically early 90s. So it's like devoid of any nice features, unfortunately. They're working on it now, but back when I was excited about OCaml, they were saying, we're a few years away from having what they call modular implicits. Modular implicit they were supposed to be this type class-like thing that allowed you to kind of say, this function is defined for anything with this kind of module defined for it and so on. And this was supposed to kind of be a solution, but it's been, I want to say like 8 years since then. And I don't think modular implicits exist yet, like now even. OCaml is, I don't like it at all, to be honest. I think it's wildly overrated. I've used it in production though. We used it with the Buckle script compiler. So Buckle script takes OCaml and compiles it to JavaScript, which is actually a uniquely nice thing. Buckle script was, I would say, comparatively great, but it's certainly a lot nicer than JavaScript. Why would you not have just an example or two? I want to show stuff to people. Why are we here now? Rescript should not be the same thing. Bucklescript was actually distinct at some point, but you might be more right than wrong there, right? So Rescript was Reason, and then it became Rescript and so on. But yeah, okay, so effectively a Bucklescript was just taking OCaml and turning it into JavaScript, right? Via the bytecode compiler, basically, because OCaml can compile to bytecode and it can compile to native code. Basically, as far as I understood it, Bucklescript was in some ways taking the bytecode and turning that into JavaScript, into nice JavaScript or whatever. Because you always had something called JS of OCaml. This has existed for a long time. JS of OCaml is basically, it takes OCaml and turns it into essentially nonsense JavaScript. Right, and this basically is not unreadable JavaScript. It turns it into. So this always existed. The entire kind of the purpose of some of these other things, like I guess Rescript or whatever, Bucklescript was, and so on, was that the purpose of that was it produces readable JavaScript, so you can actually kind of debug it and so on, because you will probably need to at some point. But yeah, that was a nice experience. And one of the reasons that kind of made sense, to be honest, was because there's no threading in JavaScript, right? And OCaml at the time essentially had no multi-threading at all, right? As is standard for OCaml to be like 15 years behind the times, right? And so it didn't really matter that OCaml had this runtime from the 90s, because it turns out JavaScript is essentially just from the 90s, right? It has no capability to run threads, so who gives a shit, right? Basically, this was the reason it uniquely kind of made sense, right? Because it's also so much better than writing JavaScript, right? OCaml as a language makes a lot of sense. OCaml as a runtime makes no sense to me. It is a high-level language, but then you don't get any of the things that you want, basically, from the runtime. Nowadays, they're doing all kinds of stuff. It's basically a research language at this point, which feels a little bit iffy, to be honest. they're doing exactly what people think Haskell is about, right? They're doing all kinds of stuff that Jane Street want to do research on, basically, with weird arenas and all kinds of lifetime things and stuff. But they don't solve the problems that people actually should have solved, right? So I don't know, maybe they've solved threading and stuff now, but I doubt it. It's yeah, OCaml is the perpetual disappointment to me, to be honest, because if you look at the most obvious competitor to OCaml in the space of high-level languages for example backend services, right, this would be Haskell. And if you look at the Haskell features that exist, it's not even a fair fight. You have software transactional memory in Haskell, which is basically database transactions but for memory, right? So you can have values that can be updated from different threads safely, and you will have essentially database transaction semantics on those values. And this is just a type annotation in Haskell and using certain functions and so on, completely safely, right? You have different versions of mutability, one of them being tvars, which are transactional variables, right? You can have IO refs, which are just normal pointers if you don't want to pay for a tvar, for example, if you know you don't need it, and so on. Meanwhile, OCaml sits there with just, oh, we have references. They're just pointers. And it's like, this is not even a fair fight. No one who actually seriously wants to actually build, backend services would conclude that, oh, OCaml is somehow, better, right? Because it's just not. The language is nicer, at least on the surface, right? The language is nicer. I will say this, right? But the runtime is just not there, right? F# is better, for sure. In terms of runtime, it's a lot more up to date with what people need, nowadays and so on. Because of course it runs on the CLR, the common language runtime, C# basically, right? And the language is nice enough. But it's sort of like someone has solved the stuff that you want to have solved for an actual backend project, for example, right? So it's, I don't know, it's very iffy, this with OCaml, right? Again, I was very into it at some point, but it's been a disappointment almost always to me to see the development of OCaml. The tooling has gotten better by miles nowadays. But every time I kind of look into it again, it doesn't seem like the runtime is particularly more well developed now, and so on. And so if I were to implement something that, seemed like, oh, maybe OCaml would work here, I think you could probably spend less time implementing it. Well, no, you could spend more time implementing it, but get a better version just by using Zig, for example. And the reason I'm making that comparison is that Zig has a language feature that is a lot like functors in OCaml. So if you look at functors real quick, a functor is basically a higher level module. So we use a function to return a module that is parameterized by another module, right? So for example, here we define an int set. This is a module, right? An int set by saying set.make. This is a functor, right? With the type is int. The comparison function that we want is compare for int. Now we have a higher level module, right? We have an int set, which is, works on those values now. A set of ints. Those are functors, right? Every module in Zig is a struct of values. You can essentially just write a function in Zig that returns a struct, and that is effectively a module. And you can parameterize this struct on these things, right? So you can say the type in this struct is an int. The comparison function is compare for ints. Now you get a struct out, you can now use this, right? Effectively the same as a functor. So the reason I'm making that comparison is because they have this very kind of, it's almost one-to-one, this relationship. Except Zig is going to give you custom allocators. It's going to give you exactly the same memory model as C, right? There's almost, I don't necessarily see the point of OCaml anymore. It fills a space that no one seems to need, right? It's not a particularly good high-level language from a runtime perspective, right? It's not a particularly good language for producing something that has predictable performance, because it uses a GC and, you know, a lot. It's a little bit too high level, right? So it's like, well, what do we do now then, right? Because who is this for? Well, in practice, it's for Jane Street, the only company that actually uses this, right? And I don't know why people are so surprised when you say, for example, there are more companies that use Haskell in practice than OCaml. This is just a fact. And if you look for example, like if you do a job search for these two, it is very obvious, right? I don't know. OCaml is a complex thing because it has this character to it that is the opposite of Haskell. Haskell has this lore around it that it's super difficult and it's only for research. And it can be difficult, absolutely. Not nearly as bad as people believe. And then they think it's for research. You can't do, for example, just normal industrial programming in it, right? When you definitely can. It looks a lot more like C than people think. But then OCaml has the inverse. No one uses it, including the people who argue for it, generally speaking. The fans of it seem to just be fans. They don't actually do anything. And it's used as a research vehicle, basically for Jane Street, to implement things that I don't know that anyone needed, right? And it's a weird ecosystem and language at this point, because again, I don't see the point of it. But yeah, that was my rant on OCaml. So anyway, yeah. I do like languages though, as you might be able to tell. At this point, I don't know how many I've used, but I would say the majority, maybe. I'm guessing I've tried basically everything at this point. No, of course not. There are so many research languages and so on. I mean, there's so much going on. There's a whole world of just stuff. Like a while ago, I was looking into Idris, right? And I mean, Idris is super interesting. I just can't use it. It's impossible to use for stuff. Idris is a dependently typed language, which means you write Idris in your type signatures to say things about restrictions on values and so on. And I don't know. There's so much promise in this model. I have not tried Gleam, but so the thing I talked about before with PureScript for Erlang is basically a competitor to Gleam, right? And my conclusion from working with Pure Erl, which is the compiler to Erlang, is basically I would probably bet on Gleam, right? So one of the reasons for this is that I think Gleam does not put a ton of overhead on top of Erlang, right? Whereas if you look at Pure Erl, it compiles everything into closures that I think Erlang is not designed to deal with in practice. You can, I mean, theoretically there can be an optimizer that does this perfectly, that removes all of those closures, but in practice it's not happening in production. I think Gleam is the best bet you have for a statically typed language on the Beam right now. That actually makes sense, right? And it makes sense in a few ways. I had some reservations. So, for example, if we look at the language store, we had this. Let's see if I can find it. I think there was a process. So the way that they handle actors, I can't find this here. Gleam actor. I think it was called actor, right? Ah, Gleam OTP. So they have a separate library for this, right? This is why the link is purple. So they have this process, right? If we look at this, we might find, oh, that's large. So I was looking at this at some point, and I had some reservations about this, but I saw that they actually solved one of the issues that I was concerned about. Right. One of the key issues when you type process, interaction in Erlang, right, is this idea of having a type on your actor, on your process, right? But they did solve this, and you can actually only send valid messages to everything and so on. And this is what I need, right? Because, and yeah, use, I don't 100% know what this was. Where did I jump away from? Let's go to Gleam Run again. Documentation, language tour, use. Right, so we have this, and implicitly when we use, we basically say if something returns error, presumably, right? So hang on. It only does, hang on, what does it do with errors though? Do you know? Because of course, like record timing here, what happens if it returns an error? Or not, well, yeah. Actually, I mean, this is the case, right? Because this is effectively what monads were invented for, or whatever. And monads are not as complex as people believe. The either monad is just basically what we already do with OK and error in Erlang, right? I've taught people monads without telling them they're monads, and they were just fine with it. And then I told them, everything you've been doing in the last few weeks, just monads. That's how they work, and now they know monads, right? Because as soon as you mention monads, people turn off their brain. There's something that happens in the brain when you tell people, oh, this is math, or whatever. And so use, they don't really say here, unless I'm... Because what happens when I get an error? When I use this? Rafael, do you know? Because let's say database connect fails. Presumably we return error out of main here, right? Of course, main is main, so, but if we were in a different function, right? Because they mention error only down here, right? Because the operation that's happening here, right, is called bind on monads. It is effectively this nesting here, right? This is what monads do when you call bind. This is this operator here in Haskell, right? And do syntax is effectively how we use this, generally speaking. Right, it should return the error, right? This is basically the behavior of bind is such that when something is the error case, because a monad always basically, generally speaking, has effectively a happy path and an error case where we just pass it through, basically. And at the end, we get a value that might be an error or a success in some case. So the classical case is either here, right? Where we have an error type, we have an OK type, right? And I would assume that this works the same way, but they're not really detailing this, right? They're not exactly being super clear about this. I would have to try this. But again, I will say this still. Gleam is probably the best case we have for actually something that makes sense on the beam statically typed, right? I do believe in it. I think, like in terms of syntax, I think they just sort of said like, hey, something vaguely looking like Rust because it's popular or whatever, which I could give less of a shit about. Like, it's not important, right? I would have preferred if it looks just like Erlang but typed, but who gives a shit? And yeah, otherwise, like, yeah, I think this is basically what we would need, I would say. I would say my next Beam project might be in Gleam, if only to see, how does this turn out? Because I can diagnose anything on the Beam, no matter what, right? So it's like, I already know the runtime and everything. So whatever problems I have with Gleam are going to be just a Gleam issue, maybe, for example, right? And so in that respect, I'm well set up for just sort of trying it out regardless. And I can't, obviously I can't see the future, but I would expect that Gleam would be fine, to be honest, right? Because it's not crazy either, right? You can look at the language and see there's not that much that's actually going on here, right? It is, for the most part, stuff that I already kind of like in other languages, right? But on the Beam, right? And OTP and everything, I've already used, so much, and I already know how to deal with, right? So we should be fine. I did make, by the way, a PR to Gleam a few years ago, basically adding the maybe type, basically making the maybe type, adding the maybe type as a specific type, because at that point, basically Louis Pilfold or whatever he's called, he was using either with a null in the right side, or the left side rather. And so the error value was null, or like nil, right? And half a year later, they ended up adding the maybe, whereas my PR was the client, because he didn't see the point. But again, half a year later, this very obvious addition was added, which peeved me, let's say, because it's one of those things where, I told you that this was something that you should have, right? But yeah, I'm not bitter. It is a little bit interesting, this kind of behavior though, because it's so obvious, but I think I had some idealistic idea that no, all you need is either with nil in the error case or whatever, but it's kind of dumb. And but I think Gleam is an interesting language. I think it does a little bit less than PureScript, because PureScript, of course, like, you run effects. Effects have their own type and so on in PureScript because it's like Haskell. So any effectful code is going to be annotated as such, right? But the way the PureScript implements this is basically you run a function that returns an effect, right? And so on. And the effect itself that you return is a closure, right? And the problem is the beam is not necessarily set up for this, right? So you might want something that does a little bit less. And that's kind of where I think Gleam comes in, because it's considerably simpler from the perspective of like, yeah, the language is not trying to do much. We're just trying to add basic type checking, you know, we're trying to have normal structs, well-typed functions, and stuff, right? So I think this is the level we need to be at, because I'm also not convinced that effects in types make a difference. You know, does that help anyone? I'm not sure. I don't think it does. You know, I think it's one of those things where maybe the idea of it is much stronger than the actual feature itself, right? Because I don't know, am I having problems with effects being executed everywhere? Maybe not. I don't know. But yeah, you don't know that until you do, maybe. I don't know. I think it's just sort of, this just is an additional complication when you compile pure scripts to Erlang. That just, now you have to deal with that, right? We have effects in types. These need to be compiled into closures. Those closures need to be somehow optimized so that they don't run super slowly. Well, the problem is sending a message is an effect. You know what we do in Erlang? Well, we send messages to other processes. All of those messages are now, they have an overhead, right? Every time we do something effectful in a process, which happens a lot, by the way, we have to now run a closure. And we can't, like, Erlang doesn't optimize these away because Erlang is not made for that, right? And so it's just, it gets complicated and weird. And we need something that just sort of tries to do less, like, you know, this, right? Is basically what we need. Normal, statically compiled stuff, and so on. I was working actually on a language for Erlang that was statically compiled, just to kind of essentially try to approach type checking from first, you know, from first principles and so on. It's an interesting problem. I was trying it at some point to statically type Erlang code only, right? Just have Erlang code and infer as much as possible. That turns out to be basically impossible for production Erlang code, right? Because people just sort of write whatever, and it's very, very difficult to get a handle on that, right? Very interesting problem though. But if you add some type, you know, annotations, you can get something that's so much better than dialyzer, right? In fact, if you gave me enough time, I could produce something that's better than dialyzer for production code bases in Erlang today. But the key actually is that someone has already done this. WhatsApp created the, you know, equalizer that is a static type checker for Erlang. Yeah, I don't have enough of an opinion on Erlang, Elixir's new types. It's obviously very early right now, and the demos that they've put out are so early that it's like as soon as you try to do anything in it, it fails, right? So it's not clear to me what it's going to necessarily be, but I think that they will probably come up with something that's miles better than dialyzer for sure. And I think, unfortunately though, they have this pipe dream of gradual types actually work, right? Where you sort of gradually type everything and everything magically is in harmony. And this is not how it works. Other people have done it before them, and it doesn't actually kind of work the way they think it does, right? So Racket did this many, many years ago, and there's typed Racket and so on, where you can gradually type Racket and so on. But the truth is, you should just write with types from the beginning, and that's the solution, right? And yeah, TypeScript is a great example of this as well. Having hybrid code bases sucks ass. It is just so bad, right? You basically need to, like, the feeling you get immediately when you try to transfer to TypeScript is, we need to do this as much as possible right now, right? Because the layers in between they feel so bad, right? Gradual typing, I don't know what world people are living in where this stuff just sort of works, because it doesn't. There are so many any's that sort of happen, and so on in these gradually typed situations, that I don't think people, like, this is somehow even worse than the completely dynamically typed code in many cases, in my opinion, right? But yeah, I don't share this idea that gradual typing is something, it just sort of works, because I've literally never seen it work. And there are better implementations that haven't worked, right? Racket has had many, I guess it's a decade or something, of a head start on Elixir in this area. And I don't think it works particularly well even there. But that's probably the best we have at the moment, to be honest, for this, right? Now, I'm not saying typed Racket doesn't work. I'm saying the only way to productively use it, if I compare it to, for example, Haskell, right, is type everything from the beginning. Put types on everything, define types, and so on, all the time, right? And that's basically how I would approach Elixir with types as well. Everything needs a type. Everything needs to be, we will have linters that say, oh, you haven't put a type on this function, this won't compile, right? Yeah, all in, definitely. This is the only way I've seen it work at all. Even in places where you think, oh, inference is the way to go. So one common thing is return types in TypeScript. Some people like to leave them out. This is a mistake. You definitely should type your return types. It will help you verify that everything makes sense. When they are completely inferred, you will get an error somewhere else and it won't make sense to you at all, right? Or the inference will somehow not work, and you should have actually guided it. And in many cases, and this is an interesting thing, when you don't put a type on something in TypeScript, the compilation actually goes remarkably slower. In one project at the company I worked at, we kind of saw this difference. We had a pathological case, right? It was bad, really bad. We put types on, it wasn't that many things, like we're talking like 30 different things, right? And the compilation actually went noticeably faster, right? Because we told the compiler, this is the type, and the only thing you need to do is disprove it, right? Because that's what a type checker actually is, a well-made one. It's a proof system that says these two predicates go together to make that predicate. If I can prove these true, that is true, right? That's all a type checker actually is in most cases, right? It's a proof system that you run. And that dynamic language, dynamic program is, in effect, it's a proof checker that runs at runtime, right? So, Python, for example, is just the logic that you're running, in effect, is the proof system, right? Because a string will still not act like a number in Python, right? So whenever you try to do the non-string thing, it will just crash, right? Whereas a statically typed language is just running the proof at compile time. And yeah, inference is one of those things people love to just be like, yeah, inference is the shit. And in some ways I understand it, right? Because if you look at the language like OCaml, right? It has almost foolproof inference, right? Almost. It is very good at this. So much so that it makes certain considerations, right? For example, plus. You have a different plus for floats and ints, right? They've made this decision so that inference works better, right? And OCaml is very nice for this, right? is almost flawless. Actually, I guess it might be flawless. I don't want to say flawless because it sounds like I'm exaggerating, but I don't think that anything, the ML languages are basically the best we have in terms of inference, I guess, right? And that's nice. It is definitely nice, right? But I think people are a little bit too focused on this, right? Because is the problem of putting a type on something, is that really big enough for us to, should we really be so concerned with this, right? Oftentimes, right, and you see this a lot in, I would say, other ecosystems have sort of developed a different view on this, probably because they have this PTSD, right? So a lot of people don't like auto in C++, and one of the obvious reasons is auto. Why would you choose auto as a keyword, right? It's very long for, I just want inference for this variable, right? But I guess they chose it for that reason also, in some ways, right? Because a lot of people don't like auto because it's not obvious now what this stuff is, right? And in some cases you actually need auto because you can't actually put a type on something, right? It's not possible at compile time to put a type on a thing, right? So function types in some ways work like this, right? So if you have a lambda, you need something auto, or auto something equals a lambda, right? For example. So it's in some ways an unnamed type and so on, right? But yeah, inference is not, the end all be all, right? I think people don't quite appreciate how nice it is to have types actually, there, right? A lot of people criticize Rust for this, and I don't quite get it because it makes things easier as well, where Rust forces you to have types on functions, right? Like if you have a function, it has to have a type, right? There are certain languages where you don't need this. Haskell, for example, OCaml, and so on. But I think that that's a great thing, right? I'm making a procedure. I have to now come up with what goes in, what goes out. I think that's a perfectly sensible way to think about the problem, right? That's how I approach this problem, right? We're writing a procedure, what goes in, what goes out. But the inference sort of crowd or whatever, there are these people who think this is somehow an inherent problem in a language, right? And this I don't get at all. Because it's just not, right? In fact, if it improves my workday, I'll put types on everything. If it makes debugging easier and stuff like this, right? I don't mind that. This is not the problem that I'm trying to solve all day, right? Oh no, I have to put types on this thing, right? But yeah, a lot of people are very focused on this, right? And I think they approach type checking from that perspective. And what I'm worried about a little bit is that people are going to use, for example, the Elixir thing as sort of like, no, it's going to be fine. Like some people use TypeScript, right? But it's not fine. In fact, it's really bad. Like we're getting shit inference. We're getting compilation errors where using other people's code, we have to be like, now we have to be hyper specific in ways that don't make any sense even, right? And there are generic functions that you have to put a type on because otherwise it doesn't even compile at all, for example. And this is the wrong, like we've put the complexity in the wrong place in some sense there, right? But yeah, I don't know. The Elixir thing, right? I'm waiting in anticipation is what I would say. And I think they'll probably do a good enough job considering, right, what are the alternatives, right? Dialyzer sucks. It's just so bad. It's basically unusable because it will be wrong. It can be wrong even when you specify in this function, we return a string. But then you can return an int from that function. That's how wrong it can be. And this is bad. Like, I don't know how because a type checker is only like a type checker is only as good as, you know, its reliability, right? And dialyzer is one of the least reliable things I have used, for sure. To the point where you may as well not use it. This has been my experience with dialyzer. And I did a talk at some point for the company I used to work at, right? We had an event and so on. And in that talk, I actually showed a case where it had this obvious mistake. Dialyzer basically allowed me to return, I think it was an int from something that should return a binary. A binary is just a string, right? And this is just ridiculous. Like, and it wasn't a contrived example. It was this function, and I found it randomly when I was writing the slides for that talk. I found it just by just writing some code. I didn't try to confuse dialyzer because that would be unfair. But dialyzer is, yeah. Equalizer though might be good. I've never tried it, right? Where did I have this? Here. So equalizer might actually work. Have no idea, right? You know, WhatsApp have made it. They do a lot of good work in Erlang. So for all I know, this makes perfect sense, right? But I would have to try it, to be clear. And yeah, actually, their FAQ might actually say something here that kind of supports what I'm saying. Why not extend dialyzer rather than creating a new tool? Okay, so basically some of the reasons here actually are it analyzes function by function, which sounds bad, but it's not actually. It does require basically the Rust model of every function needs a spec though. Oh yeah, equalizer is probably only used in Erlang. WhatsApp, as far as I know, don't necessarily use Elixir. So for them, it's sort of just worked out, right? To use it only for Erlang. But yeah, the Elixir thing, again, they're doing a bunch of research and stuff. And that will probably be cool, I guess. I'm hoping a lot, I will say this. I do like parts of Elixir, right? And it is, if you know, for me and my previous colleagues, for example, Elixir would not necessarily be a problem, despite the things I said about macros before, for example. Right, we've been able to build lots of stuff with Elixir without using macros, right? And for our code and for everything, it makes perfect sense that way. There are certain libraries that I hate to use, to be honest, because they're just full of macros, makes it unusable in languages like Gleam and so on. So for example, if you were to try to use ecto from Gleam, I'm guessing there's a layer of complete garbage between those things. There might not even be a layer. So if we search for Gleam ecto, what do we find? Nothing. Because ecto is built on macros. Yeah, I mean, macros should not be used a lot. That's the thing, right? But the problem here, for example, is that ecto is built on macros, right? So how are you supposed to use it from Erlang? Well, you're probably not. But if I search for Gleam Mobius, we might actually find that this exists. The reason I mention Mobius, right, is because let's see. It's built entirely on functions. So it's a querying tool, you know, like Ecto basically. Ecto does a little bit more, but if we search this code base, Mobius, right, for def macro, we find this using for Mobius database, and for query filter, we find this. There are 2 total uses in the entire code base. The way you actually write your queries and so on is just a functional interface, right? So what you end up with is basically just, I'm writing this, right? Take a database, filter for the name Steve, sort by this, limit by this, and so on. You can write something that is essentially like this in Ecto, but a lot of those things will actually even be macros, and so on. So it's, I don't know. Ecto is not super useful from that perspective, to me. I mean, if you try to use it outside of Elixir, it just becomes exceedingly difficult, to be honest. You need some kind of layer in Elixir that you can then call from other languages, right? Anyway, I actually have to go. This was an incredibly long stream. Of course, we didn't do a lot of code. We did this here. We talked to google.com and got some headers from google.com, basically. Printed the values, and that was basically it. But yeah, I hope the title was clear enough. We're just sort of playing around a little bit and so on. Ash framework. I don't know what this is. I've heard of it. Hang on. The link is purple. Live book, okay. Yeah, why have I looked at this? When did I do this? I don't have any memory of actually seeing any of this information. Oh, I see. Yeah, this is what I'm basically a framework of macros. Yeah, this is you're not wrong. You're definitely very right. Oh, okay. Yeah. No, people go crazy with stuff like this, and it's unfortunate. That's what I would say. Model your domain, derive the rest. It sounds suspiciously like no code or low code platforms, right? You know, do a little bit of work, get everything for free. No. Low/no code in a nutshell. You're not gonna get much. And the thing you're getting might not even be the thing you actually need at all. Don't be afraid of code. Though I do understand the reason people think like this, because programmers are expensive. Very expensive, unfortunately, right? But, you know. Anyway, I have to go. It was nice talking. I guess I will probably stream tomorrow again. I'm also planning on releasing the what happens when video, the first one in the series, the actual first, what happens when, and we'll be going over what happens when we try to connect to another server. Basically, we're going to be going over what happens when I execute this call here. Dial TCP from hostname import string. So what happens when we actually go into that function and so on. We're going to step through it in a debugger and so on and so forth. And so, yeah. But all right. Again, it was nice talking. It was nice ranting, talking about languages and so on. I hope there were enough spicy takes in this live stream that it will be linked somewhere. Maybe some OCaml people will be upset. Maybe we've offended part of the Rust community and so on. So with that, have a nice day and ciao.